be fun. Well, I was muted. Sorry, I was seeing what Dodger was doing. Sorry, yeah. This might be a little, the music might be a little quiet. No, I think that's a good volume. Yeah, sorry. What was I saying? Some dude's on the phone. No. I was trying to talk to you guys like an idiot. Yeah, so we're back doing analog audio stuff. I can't leave well enough alone. I'm sort of champing at the bit to work on this stuff, so I'm gonna work on this stuff, and hopefully we'll get some stuff done. And I'm gonna try to characterize the audio that's going through the filters. I got a couple little things to connect for these boards. I've sort of done the factory process of replicating the board multiple times, and at this point, having put in so much work, I'm like, maybe I should have just made a PCB for it. At this juncture, it might have been better just to build a little test PCB, a little breakout board for the opamps. Probably be a lot easier. But anyway, I've gone forward with actually building the damn thing. I guess you know, the chip shortage, the supply line shortages are affecting everybody. So I'm gonna make do with what I have, right? Even though I don't think the supply line shortages are affecting PCB production. So found out there's an alternate recipe in Satisfactory for PCBs that involves silica. I wish I had it. One sec, I'm gonna reposition my mic because I got like a 1970s collar going on here. I don't know, the casual folded over collar is like a weird look, isn't it? How's this doing back here? That's fine. I guess it's all right. I don't know. I gotta take a look at these. They're not done yet. This one's done. These are the two that I gotta work on. I may just start instead of letting people gather. I'll just do my thing, and people will, yeah, gather. The music can be a bit polarizing too. People don't necessarily want to listen to that. Oh, my fan's not on. Hold on, I'll be right back. Fan's not on. I'm like, why am I hot? Why is it hot over here? Turn the fan on, crack the window open a little bit more. It's gonna be like outside, getting a little wintry. It's that winter stage of fall. Might open that more. Well, we'll see. We'll see what the fan does. We'll see what the fan does here. I'm gonna get the music out of here. So what I'm really trying to do today is to finish up these 6 filters that go in the audio path of my microphone. Now, some of them are used a lot less than others, and we've all seen the chart at this point, right? It's not really so much a 6-band EQ. It's like a 5-band EQ. You know, I boost lower frequencies slightly, I tamp down some of the mids, and then I have I guess a cut filter on the high end. So I want to kind of replicate this as best I can, get kind of a similar frequency response. And I don't know exactly how to do that. I mean, you know, obviously parametric filtration, right? We're going to put a bunch of opamps in the path of our audio. Not quite like this. It's a little bit simpler than this, but that's essentially the idea. We're going to do the same thing that Elliot Sound talks about in his documentations of his various audio projects. So he's got a wonderful little parametric EQ that he uses, and he seems to like. Also, we're also under the threat of going hypoglycemic today, I have to say. I've given insulin, and I've had coffee, and that's it today. So I don't know if I gave too much insulin or just enough. There's going to be a bit of a dip. I feel hypoglycemic right now, but I'm not, clearly. So we'll see how that goes. I mean, I'm not eating lunch today, so... anyway, so I might just need to do like an OJ break at some point. Probably not, though. We're not exactly going to be like running around today. So I'm not going to be doing physical activity today. So anyway, parametric equalization. We got frequencies coming in. Our op-amp is listening to specific frequencies of that, and then you get to mix it in with everything else. I don't know if it like cancels waves or something like that. I don't freaking know. Either way, all the wibbly stuff comes in, and then less wibbly stuff comes out, or more, depending on how you have it adjusted. So it's the magic of electronics, right? The magic of analog audio. I have been struggling to build this circuit over and over again. I need 6 of these little bastards. I need 6 of these little bastards in order to run my microphone as close to what I want to get out of it, this, as possible. So 6 of these circuits. Now, these aren't all that complicated. You can see there's like 10 passive components and an op-amp. 1, 2, 3, 4, 5. Well, actually, technically, it's 1, 2, 3, 4, 5, 6, 7, 8, and an op-amp. No, it's not the freestyle. This is a tandem with a Dexcom constant glucose monitor. The Dexcom CGM is possibly a more substantial invention than the insulin pump, I would say, because you can still use syringes with the constant glucose monitor and achieve incredible control. Now, one of the things that they've done is they've closed the feedback loop. They closed the feedback loop between the glucometer and the insulin pump, which is huge. It's really big news for us diabetics, because we don't have to be as much of a pancreas 24/7. So with that technology, I've had a much better time of managing my glucose levels and stuff like that. And so, you know, this thing is the arbiter of whether or not I'm feeling good for stream. Right now, I am barely kissing the hyperglycemic end of things, and it's going to come down from there because I got 15 units in my system, which is possibly a problem. I may have to take like I said, an orange juice break if that dips, because all I've had is a cup of coffee, but that has long-acting carbohydrates in the cream, and I use Splenda. So anyway, with this circuit, there is a write-up, and the write-up has an explanation of how the values are chosen. The better explanation is actually in Project 150 instead of Project 152. Project 152 has a bit of a, like not abbreviation, but they sort of took an abridged version of that circuit where it's a little bit simpler, which I like. But there's certain characteristics of this circuit that you need to basically plan for, and the values chosen on that other circuit are values that are chosen specifically for guitar, sorry, a bass guitar amp, like a really good bass guitar amp, which is, I'm not a good bass guitar. I'm not even a marginally passable bass guitar. That's just not, that's not my personality. So what we need to do is take a look at the values that are given to that circuit over here and apply them to our circuit. Now, one of the advantages that we have, or not really, that's actually not an advantage, never mind. One of the things that I have to account for are these potentiometers. Now, this is a dual potentiometer, which is harder to find, and it's more of like a musical instrument kind of thing. It's like a knob type thing. I can't find one in an instrumentation amplifier profile, which are these blue things with a little brass screw on top of them. Those are more stable. They allow for more turns per adjustment, and they give you, I don't know, they're better under vibration and stuff like that. They're instrumentation kind of products. So those I cannot find in a dual package where there's two things that spin. I feel like I've seen them before, but these, I can't find them these days. So that's fine though, because we don't actually need to adjust that frequency so much. I mean, if I were building this and I had no previous information about what I was filtering, then yeah, it'd probably be a good idea to have the adjustable components in there. But I know, and I have a text file right here, all of the specific values that I've actually adjusted for, and assuming that these are true to life, I have no reason to believe they're not, then I can just replicate this stuff. I could even replicate the amount of gain if I knew what the resistance would be for that amount of gain, which we might need to find out. We might need to find out where the resistor has to lie in order to get specific values of gain, so we can better replicate this. It depends on where we get to with testing this thing today. So I know the frequencies that I want to adjust, and they're roughly, logarithmically scaled. I could probably, strap these to actual, like, legitimate frequencies, but as you work with the equations, the numbers are all over the place. And so it's better to cater these frequency values to commonly available components. That's actually that's the meta here. So the meta here is not, I need to adjust exactly 1008 hertz. That's not the meta. The meta is, I have a component that gets me close to that, and so I'll adjust it from there and figure out what sounds good. And that's the important thing. That's the important thing. What sounds good? That's it. That's all this is. All this replication of stuff that already exists in my system here is me just playing with the knobs until it sounds good. That's it. That's all you got to do. And so we don't have to be as engineering and as sticklers of, we don't have to be that detailed. We don't have to be that exacting. We can kind of go a little bit loose as long as we give ourselves the room for adjustment, and we can make it sound good. That's it. That's it. That's all we're doing. Right? All right. So, you got me? You got me. All right. So anyway, using this as a rough plan, I took those values, and then I took the equation from project 150, which is just very simply frequency is equal to 1 over 2 pi times R in ohms, not in kilo ohms, right? R is in ohms, and C is in farads. Now, this is really important in electronics. C is capacitance in farads. R is resistance in ohms. So when he talks about 4.08 kilo ohms, well, actually, that's the frequency, but whatever. If you talk about 4.08 kilo ohms, you're talking about 4,080 ohms, right? When you're talking about, 5.89 kilohertz, you're talking about 5,890 hertz. You got to keep your units all in the same stuff. So farads is actually fairly difficult to master, right? Farads, the capacitance in farads is tough. And so what I did is I had to use calculators in order to convert it into, microfarads into farads and nanofarads into farads. Some people prefer working in like nanofarads, which gets really confusing. 100 nanofarads is 0.1 microfarad. And then when you turn that into farads, you're adding e to the negative friggin' eighth. It's ridiculous. So what I had to do is I had to put that into Wolfram Alpha because I'm lazy. I didn't feel like solving equations, so I punched in the equation into Wolfram and I let it figure it out. I let the AI do its work. So I put in frequency is equal to 1 over 2 pi 360 2p2. So here we have a common resistor value, which is 360 ohms, and then we have a common capacitor value, which is 0.022 microfarads. And so I was able to calculate it out, and when I had it actually give me an approximate result, we can find out that that's 20 kilohertz for F. 20 kilohertz, right? So that's what I did in order to get close to the values, and then I had to plug stuff back in order to get exactly the right value. Well, from streams, they have a stream. Do they just let the AI do it, or do they actually like is it like people? I remember back in the day, my friend did not trust Wolfram Alpha because he didn't trust AI. We still don't trust AI, but I mean, it was interesting. It was like he was like one of the first people to genuinely distrust something like that. Anyway, common capacitor values, common resistor values, right? And then on top of that, oh, I see, it's the actual CEO. That's cool. So then on top of all of that, I had to actually measure all of these values against, you know, actually measure F is equal to 1 over 2 pi RC. I had to actually measure that against what I have here in the shop, because I'm not delaying a week in order to order new stuff, right? So that was a lot of what I did yesterday. It was a lot of calculation based on set values and figure out how close to those set values I could get. And of course, I kept notes in the safest place in the world in an MS Paint document. So this circuit right here, we don't need the 10K, we don't need the 100K like that, right? That becomes one resistor because we're not offsetting our adjustment by 10 kilo ohms. That was just something that Monsieur Elliot put in there in order to make that value adjustable within a set range. And indeed, in some of his other parts of the circuit, it's less tuned, right? It's less tuned. It's got a 1K ohm resistor right here. You got a 1 kilo ohm instead of a 10 kilo ohm. These are still 10Ks, but he's got a actually, he turned those into 100s. Yeah, so the range is like totally different here, right? Different purpose, different circuit, you know, different values, same structure. So what I did is I took all that stuff and I figured out what exactly my frequency values and resistor values are, and this is all subject to change. So what I had was an initial calculation here, and so I took each band at their theoretical hertz. I took a common capacitor value, and I figured out what resistor value I would need in order to achieve that specific frequency adjustment. You're supposed to keep them separate from one another, but the 73 and the 230 and the 5 and the, yeah, those are 20 and 73 are getting kind of close to stepping on each other's toes. But anyway, so I mean, I may have to replace this one and this one with a high and low cut, like a high low pass filter or something like that. That might be something that I have to do. For now, I have them in here as parametric steps. That might be bad. Which sucks because the layout of the circuits that I created have the low frequency on one of the boards and then the high frequency on another. So that's annoying. Maybe I could transfer components from one to the other and kind of mix match them a little bit. This is just me keeping track. I didn't make labels for anything. So what I did is I took the common capacitor values, right? So 0.1 UF, everybody should have a billion of these guys. 0.1 UF, 100 nanofarads. I actually found that I'm running out. I ordered about 200 of these things. I ordered more. I don't know if there's another bin that I don't know about where I put a bunch of 0.1 UFs. There probably is. I think there is somewhere. I don't know what happened to it. I don't know what happened to my decoupling capacitors. These are super common. Because the timing of this project is great. Stalled long enough in similar project. Oh yeah, and attempts to interpret that I get to watch you do it first. Yeah, right. I'm gonna stumble through the woods and trailblaze a little bit here. Elliot Sound, an interesting way to think about Elliot Sound Projects is that he's giving you the tools to experiment, right? He gives you just enough information and he gives you the functional building blocks, right? You make me wake up before noon. It's like barely. So anyway, I used a common capacitor value, one that everybody should have a billion of, one that I should have a billion of. I didn't happen to. And then I had to alter that for some of the other circuits. I found 0.22 UF gave me enough range to get to 5.5K and 20K. Because there's limitations, right, on the parts and stuff like that. So I found theoretical resistor values, and then I found actual resistors that I had in my kit of stuff that matched those values and recalculated the frequencies. And so here are the filters that we have once I finish building them, which is 21 hertz, 72 hertz, 234 hertz, 994. I couldn't quite get to 1,000, and we're only 8 hertz off. So, sorry, 6 hertz off. 5.56K and 20.095. So those are the values that I'm able to get. Now I've sourced all those parts, all the surface mount parts and resistors and stuff, and I have gotten them onto the boards. Now all that remains, what I didn't finish in my homework, is actually hooking them up. Now this may look like an absolute disaster, but it is actually a fairly organized circuit. Here's what one of the filters looks like. I have an internal debate with myself about whether or not I want to actually flip the banks of resistors, because I've got 2 banks of resistors like this that are hooked up alternatively. I don't know. Yeah, I mean, I could measure the capacitors, but as long as we're close to those bands, like I said before, caps can wander all over the place, and I'm not using precision resistors, right? All the values are going to be subject to an extreme change. I don't even know if the only thing that I have that can measure capacitors is my little surface mount tweezer multimeter. I don't even know if that's accurate for capacitor measurement. I mean, generally we've gotten close to the values when I've tested them. But in terms of the, it's all probabilities, right? We're talking, this is why engineering and mathematics go hand in hand. I mean, you know, electronics are math. But part of that math, part of that great, glorious math that defines everything that we do is probabilities and statistics, right? When you order parts, we're talking about a factory that's producing capacitors. They have a tolerance because, you know, you can't get incredible repeatability on raw materials that you're trying to produce into electronics components unless you're throwing out a ton of them. That's why they're more expensive if you get precision ones, right? So within that quality control, there's a cost factor in it. And so if you're buying parts and you're just buying generic parts, especially if you're doing digital electronics, you don't have to care. That 1K doesn't have to be quite 1K. 1 kilo ohm. What's a couple kilo ohms here and there? Or what's a couple 100 ohms here and there? Tens of ohms. It's not going to matter in a digital circuit. Decoupling capacitor, well, as long as it's there, it's going to have a little bit of time variance in like the nanoseconds when your device turns on, but you're not necessarily going to need 0.1 microfarad for every capacitor. It doesn't matter. In what we're doing right now, and as I've explained it earlier, we're not going to get precisely my calculated values. The math on paper almost never matches the real world results, right? That's just what we get when we do analog stuff. But in my system, the frequencies that I've chosen are far enough apart, and the variance in components is such that we're not going to see an incredible wandering of frequencies here. As long as I'm close to the mark, I can just adjust it for what sounds good, and that's all that matters. As long as I keep those frequency bands far enough apart and close enough to where, you know, our test case, to where my microphone is adjusted right now, keep it close enough, that should be fine. Now, if we wanted to get that kind of precision out of it, if we wanted to get the same precision out of it, I would basically just be replicating the function of the VSTs that I use in like an FPGA, and we could just program it in. I feel like that's a little bit more boring and dry than working with analog electronics. But the fun thing is with the analog electronics, you can have your system and put it together, and you can adjust it to within an inch of its life, and then you apply heat, and everything changes. So in terms of what we're working on today and this whole project, this attitude of like adjusting everything and being kind of a stickler for, you know, wandering values, I don't care. We've only got so many hours in the day. I'm not going to sit here and measure all of my components. Now, some EEs would have you do that. That's not what we're doing. We're playing it fast and loose, and we're playing it with analog electronics. So the more we learn, the better. And if we need to then circle back and do all the precision stuff, we could do that still. But I don't want to get bogged down in, here, we don't need thermal cameras. I don't want to get bogged down in, you know, measuring components all day. So I built these things, and they look like absolute nightmares, right? They look like absolute. What, thermals is still on the scene? Somehow I lost my ability to globally turn off thermals. All right, anyway, yeah. So what we have here is a dual op amp, and that has two outputs, and then it has the differential inputs. So we got ground right here, we got differentials, and then we got our output. And so we have power, output, differentials. And so I ran wires over to the 2.7 kilo ohm resistors. Those, one of them directly connects to our potentiometer. The other one directly connects to the potentiometer. So we've got in going jumping over part of my circuit and coming over to here. Then we have our wiper, and then we have out. And the wiper goes to a capacitor. It goes to a set of two resistors. The center tap of it goes back into one of the differentials, and then I've got a capacitor and a resistor here going to ground, doing the other part of the filter. Now, what I just explained is this. That very quick explanation is this circuit. Now, the only thing that's missing is this right here. I forgot to put that in. I don't know if we necessarily need it, but if we do, I'm gonna have to stick that thing in there. I don't know, you know, I don't know. I got plenty of 10K ohm resistors. It's just a matter of the mechanics of it. Yeah, this circuit is an Elliot Sound circuit, and I've got a what is it, 5 something? LF353. The LF353 I found to sound better than anything else in the microphone, so I'm using it for the parametric filtration. Now, this circuit is a little bit sloppy, but I had to build something, right? I had to get something going. If I wanted that 10K ohm resistor to ground, that would go here. How would I do that? I mean, here's ground, and it would have to go here and here. I think my best bet would be to put the resistors on top of the chip and just, or do two chips standing up, 2 chips, 1 cup, and then have them come up over to that. I mean, the underside of the board doesn't have any pads on it. That's just this kind of stuff that I used. Up. Yeah, there's just nothing under there. I mean, I could sneak a surface mount resistor onto that pin. That's possible. That may be the way that I need to do it. These ended up being wide enough. And by the way, I still can't find my metal file, so the edges of these are going to be real rough. You guys will just have to live with this. When you put stuff under the microscope like this, it looks like ass. But I spent a lot of time yesterday building these circuits. And once I figured out how it would go together, I was able to repeat things. So I wasn't able to finish the wiring on all of them. I think this one is done, except for the 10K. Yeah, this one is done. A little bit sloppy, but it's done. And then this one, I still need to finish up all the wiring on. So we gotta do this, and then we can hook them all up together, and we can figure out what's going on. And I can figure out whether or not I need those 10Ks. I'm worried about that. I can continue building it like this so that you guys can get a little bit of a sense of the size of it. But I think what I'll do is we'll just flip over to this camera, and you guys can at least see where my hands are going. Let's get the thermals back up. Let me just, I don't like having the thermals running between streams because it'll sit there and calibrate itself repeatedly for, 72 hours before the next stream. Properties, deactivate. Reactivate. Oh, bam. Okay, there we go. Oh, and then my button only works in the main scene. Man, I need to get OBS WebSockets working so I can distribute some of those tasks better. If I have to turn it on and off in every single scene with the button, I can do that more easily in Node.js. All right, so that's where we're at. I need to do a little bit of circuit building, and then we can put these filters into effect. Now, the thing is, there's going to be a little bit of troubleshooting, and I'm going to bring you guys through that process of troubleshooting as we go. In addition to troubleshooting, when we get this thing running, it's not going to immediately work exactly the way that we want it to. If it does, in the rare event that this circuit actually works, I would like to make a white noise generator. So we need to look up a couple circuits, and I'll build a white noise generator. What will allow us to see all frequencies running through this thing, hopefully all audio frequencies running through this thing. And that will enable us to use a Fourier transfer in the oscilloscope in order to see what it's doing to specific frequencies as they run through. I want to see it all at once. So anyway, I need to just do a couple things here to finish this up. I didn't finish my homework. All right, so this one compared to one of the finished ones here. I can just pluck this out. I put the potentiometers in sockets because it was easier to solder them. And then I can just plop the potentiometer in there, and also I can pull it out and measure it and figure out what resistance it has. Because I could do fixed circuits on the mic pack, although I probably should keep it to potentiometers so that I can adjust for a specific microphone. So what we have here, let's see. I just need to remember how I'm building this thing. Middle pin output to the capacitor, and then it goes through the resistors, and then that one jumps down. That is a junction that jumps around and over to the pin. I've actually been doing that the opposite way so that I can separate this wire from that pin, because that's not supposed to make a connection, and this wire turns into soup very quickly. So yeah, let's do a couple of the remaining connections here, and then we can get rolling with these filters and figure out. I don't know how I'm going to test these initially. I could just try to run audio through them, but we don't know if the gains match up. Like, how much gain does it expect to see on the input? How much on the output? We are running it at 10 volts, so that could have a different effect. All right, so I'm going to tin some of this wire here. Yeah, I got the fire within me to work on this thing, so I'm just going to work on it. Got a lot of work to do anyway. Really, we should be designing solids in Fusion today, but I decided against that. This was my Wednesday. It was building these circuits. And this is my method of using these square pinned perforated prototyping boards to make surface mount circuits. I've had a lot of practice at this. All right, where am I going? Okay, so this will go across these two, and then I have to make it do a tight bend. I could do it like a T and have it go in the middle there. I really should have spread out a little bit more for the circuit. You know, it would have been a lot easier to see what was going on. But my methods got the best of me, and I wound up making this exceedingly tiny as sort of like a filter module that I can drop down on a perforated prototyping board, or sorry, on a solderless breadboard. Man, keep getting those two mixed up, huh? The problem is these cutters, they don't complete the cut. They don't complete the cut. And then one thing that I need to build is a set of hot tweezers. I need some hot wire tweezers. They're very expensive if you just buy them, right? You can buy hot wire tweezers, but I would like to just make some so that I can strip this little end of wire here. I haven't been using this method as much as I would have liked since making PCBs is like super easy. Like we could spend a couple minutes today and I could end up with PCBs ready to go for this project and just send them off, and then in a week I get the real thing. But Rossman has of course Rossman has a pair. Rossman! What's up? What's up, Cannibal? Jesus. Yeah, so hot wire tweezers, and then you just pluck the end of the wire. God, that would be so nice. That'd be so nice. My method is to heat it up with the iron and then just like, yeah, He's teaching classes. Was he as belligerent as you fuckers are when I try to teach? You guys were off. You guys were just off the charts when I was trying to like teach stuff. The vacuum desoldering guns. I don't know if they're as useful as they play to be. I don't think they are. Where's my circuit? There it is. I need to move this one out of the way. I'm just trying to keep them in order so I don't forget which one's which. So I don't have to look up values. Yeah, solder pots are okay if you have a lot of, if you're building like a wiring harness, you know, shit that like Gonad does. If you're building like a big wiring harness, solder pot is good, but a solder pot's like a huge liability because you have this incredibly hot, just like molten solder pit. What people are talking about with a solder pot is basically you have a vessel that's being heated to keep the solder molten, and you dip wires into it in order to give them that tinning and appropriate stripped out level. I also have a hot wire, a hot plate wire stripper where you put it on the thing and you twist and then you get a perfectly stripped wire. Those are great too, but all these tools, you have to take them out and turn them on, do all that stuff. Yeah, dangerous to have on a desk. Yeah, and they take forever to heat up. So I mean, like, I just use the Star Trek, you know, the engineer, all the text is gone. It uses the Star Trek Next Generation font, but it's just a engineer SSO2 solder sucker, which does just fine for everything I need it to. This thing's actually showing its age a little bit. Yeah, it's not as good as it used to be. Huh. I gotta replace the tube and I can clean out the insides, which I already did. Ugh. You're not gonna, like, I don't know. These tools are for people who do this stuff way more than your average hobbyist. And in my opinion, all they're doing is discouraging people from getting into the hobby. Because it's like, oh, I gotta spend $300 on a desoldering gun and a solder pot and all that stuff. When these are the tools that people who do this stuff very often are using. Get that away from the... This isn't the prettiest way to put a circuit together, but it works. Yeah, doing this on the microscope is actually not an advantage. The microscope makes me want to do it prettier, and when I didn't have it on the microscope, I was just getting it done. I crushed the wire a little bit there when it was hot. Sucks for the jacket. All right, so there's that connection. Need to get that out of the way of that pin. Otherwise, it's going to become a permanent feature. I want that to conduct. And I need the output wire here. So let's get that ready. So it's going to be a white wire, just so that I can mark which one is which. Like that. Strip the end. Vacuum desolder. Yeah. Do you have one of those transformer, the hot solder, the wire stripper? It's basically just like a tapered slot plate. I've got one and it's sitting in a drawer. It has been for a long time, but back in the day when I had to do a lot of wire harnessy kind of stuff, it was a wonderful tool. Green Raven, hey, thank you for the 2 months. That's a streak. That's gonna be a streak. I appreciate that, man. Your name is going to go into a list of names, what are going to arrive on the board first. And those first names are there to keep there from being a mad rush to be the first person on the board. So I will get back to working on the board. I just had to put this to bed. I put a lot of work into this on Wednesday, and I want to get this done. You know, we're still testing to see what sort of results we're going to be getting out of this kind of stuff. So I'm building a little soldered board, but this little soldered board is actually just a test. This could all end up in the garbage. Such is the fleeting nature of this kind of stuff. Oh, it's a little too long, isn't it? I want it to... I don't want it to overshoot on that end. There we go. You just use shitty wire strippers. Gotcha. You need to be able to twist the wire in order to use those other kinds of strippers, or you hold the thing in your hand and twist it, which is bad. That's a bad operation. Yeah, Chip Quick is a little bit expensive, but I mean, it's a godsend. It's such a good material. All right, let's get this header in. Oh boy. This is where things get a little janky because I built this too small. I built it too small. I bit off more than I could chew. Well, it's not more than... I bit off exactly as much as I can chew, and that leads to ugly chewing. I'm sitting here smacking my lips. All right, so I got to get in from the side of this thing. So I'm actually going to move the stool, and I'm going to crouch. Oy. Go. Doing my squats. Oh, that's the one that's already built. Here's the one that I'm working on. Oh, how do I get in there with that wire right there without ruining that wire? Like that. Mark 1 eyeballs. Don't fail me now. Oh, that caused chaos. Hopefully manageable chaos. No, I don't think so. I think I need to use the microscope on this. I can't see. Can't see through stuff. I don't have bionic vision. Oh yeah, there's all kinds of chaos. Caused all kinds of chaos. That wire's sticking up in the air. There's the wire that I'm soldering in. Hold on, I'll correct that in a minute. Hold on. Nothing soldered. I just added a bunch of solder. Yeah, this is where it actually gets very difficult. All right, so I'm just gonna work, get this done. I'll check back in with you guys in a minute. I think I solder bridged that. That might actually be viable as a solder bridge connection. Oh, but I still need the wire to go out of that, so I'll probably have to desolder that a little bit. All right, so I'm gonna stand up here. Get over here. This one's got a little bit more wiggle room. Middle one needs a solder bridge, which is an unfortunate feature. Unless I want to sneak in a wire, which I have done on the other one, but it's easier just to wang a bunch of solder into there. All right, now I need to check over and get the white wire back in. Back to the stool. Pick this up a little bit. Take a look at what happened. That one's good. That one is isolated. That one is a solder bridge, which I can live with. I can live with that. But I still need the output wire on that one. So get the output wire. Sneak it in. Sneaky, sneaky. Sneaky, sneaky, sneak. Nope, that's above. I got the parallax of the microscope here to deal with. Yeah. Yeah, I should have spread out a little bit more with these. I could have made this a much larger circuit. And it would have been easier to alter because it's still, after all, what's going on here? This is still a test circuit. All right, I know it's not soldered over there, but I guess it's all right. I'm gonna leave a little bit of extra just in case I need to get in here. And then clip it. Yeah, it's not gonna look pretty, but it'll work. If I'm lucky, I could probably just get this to retract just with heat, but I don't think it's really gonna be that accommodating. Yeah, it's not. All right, so I'm gonna melt it a little bit. Melt it a little bit. Expose a little bit of wire. Add some solder to the end. This is where hot tweezers would really come in handy, huh? Hot tweezers in your area. And the output wire goes to the output pin. Right here. See, I was doing this just by, oh God, look what I did to the jacket on that one. I was doing this just by eyeball before, and it was working out just fine. It's the microscope is actually kind of like, microscope's actually not an advantage here. It'll show any of my mistakes, which I guess is good, sort of. But it'll also show all this janky stuff that I'm doing right now. Yeah, the microscope's really not doing me any favors. It's really not doing me any favors. All right, let's get this one. This circuit was too small, too small. My advice is to spread out. Spread out. Yeah, it's really like showcasing all of the jankiness of the circuit. Did these in like an arc, and I don't know why. Polyglotypus. Hey, rating with a party of 28. What y'all working on over there? How's Polyglotypus doing? Yeah, polyraid. Sorry, the chat is very small. Welcome to my shop. You may already know who I am, some of you. I mean, the people who are already watching. Welcome to Oh Bother, Twitch TV Oh Bother's channel. This is my shop. This is everything that I own in a tiny little room in my house. We are working on analog audio stuff, and so I am building a surface mount circuit because most of my parts are surface mount, and I'm building a, yeah, it's not Oh Brother. I don't know why people get that wrong. Reading is fundamental, kids. So what we're doing is we're building an analog circuit. You know, if I saw a wonderful thing on Reddit today that said if you hear somebody's name and you think of a joke, it's likely that they've heard it 1,000 times. If it's over 1,000. Anyway. Yeah, you go do your thing, man. That's thank you so much for the raid. I appreciate you dumping 28 people on me and saying, "Hey, entertain these people." I'm gonna go. Because hey, man, at the end of the stream, you just don't want to talk to people. No, it doesn't. It's actually toxic. Anyway, so this is my shop. Everything I own is here. We're working on electronics. My component stash is almost entirely surface mount. I appreciate surface mount over through hole. But the problem is we're working on a sort of more of a through hole era kind of circuit. It's an analog equalizer. It's an audio equalizer. So what it's doing is it's taking specific frequencies and it is either enhancing them or it is, I say tamping. I think tamping is the right word, but anyway, it'll reduce the amounts of other frequencies, right? So this is based on an Elliot Sound Projects project. My microphone, the lavalier microphone amplifier that I'm using right now, is based on another Elliot Sound project, and it's called Project 93, and it is just a dual op-amp audio amplifier, right? Where did that one go? Here it is. So this is what we have, right? So I got a little tiny electret microphone coming in here. It's like a movie quality electret. Comes in and it gets amplified by one op amp, and that puts it up at line level. Is it line level? It's XLR level with a certain amount of gain. And so that ends up getting output directly to the XLR. On the other hand, we have another op amp that's creating the opposite signal so that there is a differential there. And that differential helps get rid of common mode noise. Common mode noise will hit two you know, hit both of your signals at the same time with the same level, and that can get filtered out fairly easily, right? In addition to that, I mean, there's this part of the circuit over here. What that's doing is that's just ensuring that phantom power can power everything else, because phantom power exists on the line in addition to your AC audio signal. So what this does is this keeps that AC audio signal out of your actual power lines. So you have stable power and everything works. In our case, we broke down the Elliot Sound Projects project, and we have a point here where we can insert the equalizer. We can insert the equalizer there, not accounting even for gain and stuff. I didn't account for gains and things like that. So we're basically just taking these and we're doing our dumbest to staple everything together. That's it. That's all we're doing. But it's taking quite a bit of effort because we tried to put in a graphic equalizer, which is where you send all of the audio to all of the circuits, and then they either pass through the frequencies or they don't. That's your graphic equalizer. So the graphic equalizer on the output worked. We got one of the circuits working. We didn't get all of them working. I'll have to build more of those. But I jumped over and I did the parametric equalizer. So the parametric equalizer, your wave comes in and each individual stage gets the whole thing and alters it as it goes down the lane. So I need to have 6 frequencies on this, theoretically. It's not really 6 frequencies. It's more like 4 and then a high and a low cut. But I'm trying to replicate what I got digitally through my VST plugins. This is what I get digitally through my VST plugins. It turns this mic into an actual microphone instead of like a one-for-one nature recording device, right? Anyway, that's what we're doing. I don't care what you guys are saying about what I should and shouldn't be doing, because that's what we're doing. We're playing around with analog audio, and I am just now getting these together, these circuits right here. So I have all of these built up. I know, like, it's like, hey, are you sure you should be doing this at all? No, that's why I'm doing it. Jesus. God, you guys. I'm not using exactly the parts that are set out in the schematic, by the way. 5532 is not what we should be doing. But I've boiled the circuit down to this. There's an equation that gives the frequency, and then I looked up what parts I have in order to get close enough to my digital settings. So all of this stuff is all probabilities, right? None of these components are going to be exactly what value they say they are. And the reason that I keep saying that is because there's always somebody in chat that'll say that. There's always somebody that'll say that. Yeah, these aren't going to be exactly where they are. I mean, geez, I don't have, you know, if I really wanted to, I could sit here with the multimeter and I could figure out exactly, I don't know, the 5532 is great. It can have its own whatever. It doesn't matter. I'm not using it. I'm using a LF353. It doesn't matter. It doesn't matter. I found one that sounded good that I happen to have. That's the thing. We're in a chip shortage here, folks. It's hard to get stuff. So just use what you got. And I happen to have archives of old stuff. So anyway, man. So anyway, all this stuff is relative. You know, these frequencies that I chose were not, you know, gilded to me from on high by the gods of audio themselves, right? Led Zeppelin didn't descend from the clouds and say, hey, use 72.36. And I was like, okay, you guys could just call me in the future. No, like I literally just took bands that were close to whatever the marks were, and I recorded myself saying pop, pop, popsicle, test, test, testicle, bike, bike, 1, 2, 3. That's actually bike, bike, bicycle, pop, pop, popsicle, test, test, 1, 2, 3, right? I just said that over and over again while moving the thing up and down, and then I watched the video with headphones on to figure out, okay, oh, it sounds good right there. That's pretty good. And that happened to be off from like the regular decade marking by a little bit, right? So all this stuff is super relative. All this stuff can, like the frequencies can move around, the gains will move around as well. It's whatever, like I said, it's whatever sounds good, all right? So yeah, when people get into the weeds on this stuff, it's It's not good. You'll kill yourself. You'll kill your project by getting into the weeds. You want to get it working, and then you can adjust from there. So originally what I did is I got the microphone circuit working here. Now this is a redo of the microphone circuit, but I did something similar back in the day. I built the microphone circuit, and then I tried a couple different op amps in it. And the one that I happened to have that worked the best is the LF353. It works at the voltage range. It's got good gain on it and everything. It's got low noise. I don't know how much noise you're really going to be introducing into here, but the LF353 worked for me because I happen to have a bunch of them in a bin. If I had another op amp, I'd probably use it. But we did try a couple, and they didn't quite do the right job. Now this is just here for space. I don't have anywhere else to put all the wire reels for the time being. But I got to finish this circuit. I got to finish building this because each of these little packs that I've made are 2 filters. So we got our 246, right? And I got the highest filter here and the lowest filter here. And we got to hook these up in line with the rest of our circuit. But I got a little bit of wiring to do. These are kind of difficult to come about just because of the nature, the layout of the circuit was not great. You know, maybe that's on me. I could probably have spent a little bit more time rearranging this thing so that it made sense. But I have to finish soldering this. Now, it may look like a big mass of boogers, and it kind of is, but at the same time, I challenge you to work this small and have it look good. The microscope does not do me any favors in this sense. I could have just printed a circuit board at this point. Probably would have been just about the same amount of work, if not less. But I don't want to commit to this design before I can put together things in the Jankotron and figure out whether or not they work. I don't like that solder joint. Hold on. So yeah, when you work this small and you build stuff by hand, it's going to end up looking a bit janky at first. But this is, after all, just a test circuit. So if we get good performance out of this, I can then commit the amount of work it's going to take in order to make this into an actual PCB, and that will make everything nice and clean. But for now, a connection is a connection. I don't judge. Just got to lay that out, because there's a lot of people in chat that want to sound like experts in this stuff, and it's like, all right. All right. I get it. I would never stoop this low. How could you possibly have this kinds of workmanship? Of course it doesn't work. Your work sucks. I'm better than you, streamer. Ha 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 ha. I eat another Dorito. And then I belittle this person's work. Yes, internet. All right. So yeah, this method of stripping the wires is not great. If I was Louis Rossman and I had $300 to drop on a pair of hot tweezers, then I would absolutely buy some for doing this method of doing the wires. Now, I've done this before on stream, and I'm not talking about any of you guys today, right? I'm doing that impression. It's not you guys that I'm like this with. It is I have done this so many times on stream that I've seen people like this. So you guys don't got to worry about anything. But yeah, this is a sloppily built circuit. We're going to see the performance of it, and we're going to troubleshoot it, and we're going to get it working. Of course, I'll have to bypass my audio filters if I want to do that, which means no compressor. I guess I could just... Why is this not stripping off? What is going on here? So yeah, I'll have to mess with my audio setup to get this running, which means I may have quite a job for me by tomorrow if I'm gonna, you know, I'm gonna have to reinvent all of my audio because my current setup doesn't allow me to save any of the parameters. Nah, that's not true. There's not always an actually person in the chat. You guys are fine. You guys are doing fine. I know the problem is when I say stuff like that, people end up thinking I'm talking about them specifically, and I'm not. I'm not talking about anybody specifically right now. You guys are good. You guys are just fine. Don't want to ostracize any of my viewers, you know? That's our power line. This is our other power line. And then I got to solder in that header. And then I think the circuit is done. Celia Russell, gifting a sub to Leb TV Live once again. Thank you so much, Celia Russell. Celia Russell. Thank you, Celia. I appreciate the gift sub. That benefits me, not Leb. Psh. Look at how sloppy that is. I hate it. I need a hot tweezer. I need those hot tweezers. I need to figure out, like, there's probably like a couple maker projects. I mean, I could just take the transformer from my hot wire stripper and just use those terminals with little pieces of metal on the ends of tweezers. I might have to figure that one out. That'd be like a parallel circuit. I don't know if I'd blow up the transformer or not. Probably not. Probably not. Probably not, if I just have the right material on it. Look at how sloppy that is. Leb TV is my reason why I don't go to a tier 2 sub. Hey, that's all right. That's all right. You're doing right by Leb. Leb and Celia are some of the oldest viewers of this channel. They're still around. Leb has helped me with countless production things. Celia's helped me with countless 3D printer things. She's probably the reason that my 3D printer works at all. At least initially. The soldering iron has now turned itself off. It thinks that I'm dead, and it turned off the soldering iron because it thinks that I've died, and I'm going to burn down my house. So in order for fire crews to actually recover me, and I can have an actual open casket funeral, the soldering iron has done me the favor of turning itself off midway through my working on the circuit. So now I have to push a button on the front of the soldering iron in order to tell it that, actually, this one was a false alarm, but you'll get it someday, buddy. So there we go. All right, now the iron's back on. And I can attach this wire here. Having two wires attached to one junction is a curse. You can get lucky like I did there and have them just happen to hit the right spot, but it oftentimes screws up. And then this wire in particular, when I have to grab it with the tweezers, I end up crushing the jacket. Butane irons work well. They're good at putting a lot of BTUs at the tip at any given point in time, and they'll usually have a fairly large heat reservoir on the tip. I don't use them permanently because butane fumes are not good. I don't like having them around. The butane fumes, they heat up quickly, but then they don't have any sort of a temperature regulation on them. And so you can damage electronics, you can lift pads very easily on your circuit boards. You don't want that. You know, I have a high wattage iron, but it's got very strict temperature control on it. Okay, eeny, meeny, miny, mo. What am I doing next? I need to attach the lines to, I need to attach the socket for the potentiometer right here. And so that gets the connection with those two wires, and then I need to make a solder bridge right there. This is why I put it in sockets, because otherwise this would be too cursed. Now this is the last bit that I need to do, aside from adding those 10Ks in there, the 10K to ground, which I'm not sure if it's totally and wholly necessary. Let's look up the text for the project once we get this in. Now to get this in, it's not gonna look good for you guys because I need to get in here from the side. So I actually need to get off the stool and do a squat by the desk. So I'm just gonna do it, but I'll do it with a face cam going. That way at least chat is large and I will be small. All right, I'm gonna do it now. Be right back. Gotta go to the basement. Oh. All right, get down low. Get low, get low. So I haven't had a chance to look at Poly's stream. Is it cool? I assume, since you guys are watching, that it is indeed cool. Ow, owie, ow, 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 ouch, 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 my bones. All right, I think I got that. Let's see if I can just straighten it a little bit. And then I need to get the two other pins. So this does not look good on the microscope. Squats and soldering. That's right. We're going to have steel cut oats, and we're going to do squats and solder. We're going to get ripped. And they will accept us for our swollenness. All right, I'll have to drop a little bit more solder on that. But for now, get the side pins done. It's getting harder for me to see for some reason. No, soldered to the wrong thing. Okay. I accidentally added solder to the wrong part, so I ended up just putting a big blob right there instead of actually soldering that pin. This is the problem with the way that I've decided to build this. My advice to future generations is to spread out. Do not try to build this as small as possible. I happened to build it as small as possible, and I should not have. That was just the way that it ended up. And then since the nature of this thing is repeating structures, I ended up repeating it to the other two circuits. But it's kind of a curse. Kind of a curse. You know, I could have had a power and a ground rail and then built this with enough space that the rest of the circuit would be easy to sort of like differentiate from itself so you could actually see what was going on. But I went all in on the one idea, and I got to stick with it. Actually, it's going to be easier if I just move that wire. My legs are falling asleep. I've been in a squat for minutes. Minutes and minutes and minutes. I remember what it felt like to have feet. No longer. Okay. That is now soldered in. Goes to the right spot. I can get this back in place. Oh, there's a big exposed piece of that wire right there. I got to be real careful with that. That could be a problem. That could be a big problem. If I don't manage it properly. I'm just going to like scooch it way out of the way, and hopefully in the future I don't crush it. Look, eventually this is going to become a PCB, so all I need it to do is work. It just needs to work. We'll figure out what the problems with it are as we test it in a minute here. Slime VR sensors? What are you talking about? That's weird. That's a weird sensor. The YouTube termed PCB is a populated component board. Kind of works here. Look, you know, all the criticisms that I get against my method, I've built this thing in a day and a half. So I don't have to wait for anything to complete. I don't have to design anything. I can just put it all down on a board. Those of you who have actually done stuff know this. And all the criticism comes from people who don't do. It looks like hell, but it'll work. Oh, I gotta stretch my legs a little bit. Whew, let the blood get to my toes again. Man, all right. So yeah, it's not a neat way to do things, but it'll get it done, right? So what I am gonna do next is turn this thing on and actually get audio. Well, not audio running through it. We'll get power running through it and see what happens. We can go back to the frequency sweep that we had before. We can observe what it does to the gain of the circuit. We don't have an amplifier on the outset, and I need to break some stuff down on the perforated prototype, on the solderless breadboard, so we can get all these things in there. These span 2 rows because they're so wide. I made them wide, which I had to. I could have probably made them tall, but the circuit would have been really weird. Yeah, maybe I could have made them tall. They would have taken up a lot of room though. This just happens sometimes with stuff. So you just get it done any way you can. So these have to span across the center node. Oh wait, I did not finish. Dun dun dun! I got 2 wires to go. 2 wires to go on this one. Otherwise our whisper down the lane audio isn't going to work. And I could take out the multimeter and test every last connection on this thing. It probably would be a good idea, but I'm not gonna do that. Some people are sticklers for that kind of thing. They spend a lot of time vetting out their whole circuit to make sure that everything makes a good connection, right? Before actually putting it into practice, but yeah. Yeah, I mean, my advice still stands. Make it big, spread out, make it larger than you think you need to, and make mistakes. When you make mistakes, you learn how not to make mistakes. You learn what happens when you make mistakes. Sometimes those mistakes will cost you money, will cost you time. But if you calculate out everything, you're going to get real bored of this hobby real fast. And it's important to stay engaged. So make mistakes. All right, so moving that out there, moving this one in here. It's like D&D. It's like you can play everything super cautiously, but that's not what you're supposed to be doing in this game of heroes. You're supposed to take risks and stuff, right? Make it exciting. What's the point otherwise? Okay. So, let's add potentiometers to all these. And I'm just going to power it up. I don't give a crap. We'll see if this works at all. You know, I don't know where the gains are. If I get audio out of the other end, it's going to be magical. But it's likely that we're going to have to take this stage by stage to get everything up and functioning together. But we can play around with it until then. I can go for the Hail Mary and see whether or not I actually produced something that works. So where are we going to build this? I mean, I guess here is fine. This is right near the Zener diode from the previous. I got one row on one side and two on the other. I can just do this, and then I can run power to them, and then I can run the ins to the outs. I guess I can go across, because that's kind of how I built it with the different frequencies. We can put a frequency sweep through it and see what the effects are. I don't know where these things are adjusted to, these potentiometers. They could be anywhere. We got to break down this circuit too. We never got a chance to test that. That's the same circuit, but it's built on the perforated board. And turns out my lack of through-hole parts really bit us in the ass there. Darn it, the one I dropped on the floor, of course. All right, I'll grab another one. It's a joint tracking device. That's what that is? Huh. Is it just a suit of a bunch of those resistors on it? I mean, they've gotten real good at, like, I mean, you can get a Connect. I have a Connect. My problem is my freaking VR headset. Oh, there it is. God damn it. My problem is that my VR headset decided to stop working. It's got something against what I did. That wasn't today. Fine, whatever. Fine. All right, let's get the solder out of here. We don't need that right now. All right, so how are we going to determine whether or not this thing works? I mean, I can plug it in with the setup that we had before, presuming that all of our connections are the same. Let's, clean the board off, get the wires out of here. we're gonna have to get into this circuit and like troubleshoot it. Now, here's the deal. I don't know what this one, what's that? Open Connect projects completely documented the Xbox 360 Connect protocol. Maybe the protocol, but we tried to do 3D scanning with it and we weren't able to figure anything out. It's really annoying. I wish I could have gotten a 3D object scanner out of it. But yeah, this right here, this 10K I did not include. I don't know if it's optional or not. I don't know what it's doing. And so, I don't know if I need to put it in there. If I do, I'm going to have to get clever with the soldering in order to get it in there, because I forgot it. I forgot it in the circuit. What exactly is that 10K ohm resistor doing? In his write-up, that would be R8. Let's look up R8. Control F. R8. R8 is optional, and 22K is shown. Increase the maximum boost and cut to 12 dB. 12 dB. 0.26, 0.76, 0.44, 0.85, 0.47. This is the only one that has a lot of gain, and that's just a high frequency cut. So I think that's okay. Definitely sticking around to this channel because I have a few electronics things that are broken and I have no idea how to fix them. Hey, yeah, I like ran out of stuff to take apart. We used to do Teardown Fridays, and I still want to do Teardown Fridays, but I don't have stuff to take apart on Fridays. You know, sometimes every now and then a friend of mine will come up with like a broken device and be like, hey, you want to take a look at this thing? It's probably dead. I had a friend do that with graphics cards with me recently, and I'm like, you know, graphics cards are so well documented that there's really nothing that I can say about them that would differentiate myself from other channels on Twitch, because I could just look at a graphics card and we go, ooh, it's a graphics card, look at that. We've done that with several older ones. The only good one was the ancient IBM graphics processor, because that one actually had 7400 series logic chips on it, which is awesome, because logic chips are cool. But like looking at a graphics card, we're not going to learn anything new that you wouldn't get from just like turning on Linus tick tap tip tap tap tip tip tap 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 tap. Linus trip trip. I like taking stuff apart though, taking apart all kinds of game peripherals like joysticks. I've fondled my joystick all over Twitch. It's beautiful. You know, throttles and controllers. A lot of different controllers. The Ouya controller was an interesting one because if you hit a button and hit a trigger button at the same time, it would cancel out your button being hit, as if the creators had never played video games before. So we find interesting stuff like that. We had the Turbo Toucher, the Turbo Touch. Oh, what an unfortunate name. Yeah, I got my kid a Turbo Touch. Oh. But yeah, the Turbo Touch was interesting because it was a Nintendo controller, and the Nintendo controller, an interesting thing that some of the tool-assisted speedruns do is they hit forward and backwards at the same time. The Nintendo controller did not let you do that. It had a shift register in it that would sense all the different directions, and then the physical design of the controller means you'd have to like crush it in order to get both of those to hit at the same time. On the Turbo Touch, the Turbo Kid Touch, I mean, the Turbo Touch for children, that was a flat pad. It was like a touch pad, and so you could very easily hit forward and backward at the same time. So in order to get around it, they had a very simple 7400 series logic circuit that said, if this was touched, this cannot be touched. Pretty cool. It was cool stuff. Yeah, everybody had one back in my era. Everybody, not me, because I didn't have all the video games. Actually, we had a lot of Nintendo games. We had a lot of Nintendo games. Hey, thanks for the follow, Emil Cool. I never had one, but all my friends did because it had the turbo buttons. And the turbo buttons were an oscillator. So it wasn't a 555, I don't think. I think they did a logic oscillator, and they slowed it down. They had a logic oscillator that went into the logic area so that when you had the switch turned on, it would flip a gate back and forth. And so when you hit the button, it would hit the button at whatever rate you specified. Very simple circuit stuff that they were able to make into a controller that everybody had in the early 90s. And then they inevitably spilled soda on it and decided that turbo wasn't worth it. And so you, as second player, visiting the finished basement that still smelled like carpet, would get handed this sticky fucking controller where the A button doesn't unpop. Mutia, thank you for following. So yeah, R8 is optional and gives us a little bit more gain control on the circuit. We'll leave it out for now because I forgot to put it in. Mainly because I forgot to put it in. All resistance values can be increased by a factor of 5 to 10. I have absolutely no idea. I just followed later advice, yeah. PC turbo buttons, yeah, that's a different animal. My controller had an analog stick chewed up by a dog. Ow. You can replace those. At least now you can. All right, let's get this out of here. Get him out of there. Open the doors. Get him out of there. So this is the graphic EQ, and we only got one of these circuits working. If I really want to, I could probably do this to the graphic EQ, but all these little surface mount components, I'll put in a miscellaneous bin somewhere. Maybe one day. Maybe one day I'll use them. Probably not. Probably not, though. Get all these out of here. I need these jumpers. I don't need these resistors. Those are gone. Those are 10Ks, I believe. Uh-oh. Nope. I got 10 volts on the board, so we're not dealing with dangerous voltages here. Let's put this in a miscellaneous bin. Really? Yeah. You know, you could buy broken controllers too. That's what I did. I think the Ouya controller was new. But like I also found like Micro Center like Supercell controllers. We took one of those apart and it was just like this generic Wii controller, and it actually had some good hardware in it, to the degree where I stole some of that hardware and it actually is in possession of the famous streamer Tom Thinks, because I built him a little button. He had some orthopedic, is that right? Anyway, he had some trouble with the foot pedal because he's at a standing desk and he had a foot pedal for his Roland voice changer, and the foot pedal put his foot in such a position where it was going in a direction that human bodies don't really like. So you're standing and your foot is like, I can't, how do you, okay, you got your leg and your foot, and so it was going like this, and it was overextending like upwards, and it hurt him. It was not good. So he experimented with moving the button around, and what he ended up doing was he took apart the foot pedal, and inside the foot pedal it was just a little rubber dome that was hitting up against the PCB, right? Which is, that's fine, it's totally kosher, but he taped that rubber dome to the PCB, and he had that sitting on his desk where he would actuate the thing with his thumb. I was like, that's not going to work. So what we did is we took the button out of this generic Wii style. It was actually an Xbox style, but it was for the Wii, and I think it worked with like another console. It was a very generic controller, but on the trigger buttons it had big rubber domes, and I was like, all right, these'll do. So I took that, modeled it in Fusion 360, built a housing around it, put a headphone plug on either side. So now Tom has this cute little like buttony thing with his toot emote on it that he can press in order to actuate the voice changer. He had to add a little bit of foam to quiet it down, because otherwise it becomes extremely audible on the microphone, which I didn't have the experience of. My microphones are a little bit more tuned. But yeah, he added a little bit of foam, and now that's in regular rotation at his over on his stream for his meteoric rise to fame. That was a slam dunk project though, because that was right in our wheelhouse. It had to do with gaming peripheries. It had to do with human design, which I've dabbled in. I've more than dabbled in. I used to work for a medical device company, medical device testing company. But yeah, that was like right up my alley. That was super cool. So yeah, here's our audio circuit here. This little loop is our patch in. This is where we're going to add the EQ. We don't need a virtual ground. We've got 10 volts in ground. This thing has been designed for 15. So we've got all kinds of stuff that's affecting our gain, right? Use a Wii remote that is Bluetooth to track the foot. Oh, God, no. No. Needs to be more simple. That's the slam dunk projects are the ones that are like super simple. And even when a project is super duper simple, it will take me a long time to do because I do it in an entertaining way, right? Counting connectors, 1,240 pins to solve the next batch of work. Why are you not using a hot pot? Why are you not using a solder pot and an electric stripper? Not what you think it is, chat. All right, so we need power, we need ground. Where are we going to get that from? Well, I could jump it from the center out. Probably better if I put it out in the open. Probably better if I put it out in the open, and that means I need larger jumpers, and that may not be possible. That's not possible. It's not possible. Can't do that. Is that legal? Hold on, let's see. Let's see what I got. Look at all this breadboard mess. Yeah, one of the harsh realities of working in electronics and having fun is that you need to be the type of person that's totally fine grinding in an RPG. Because you're gonna end up grinding stuff like I am here. I'll just do it from above. No, power from above. So yeah, power from above. Power from above. The grinding in this case was building these tiny little friggin' circuit boards, but in the other cases, you have thousands of connections that sometimes need to be made. And you just gotta do it. You gotta be the type of person that's willing to put in a little bit of work to get that reward. Although these days, let me tell you, these days, there are so many good shortcuts. There are so many good shortcuts. Oh, it's a beautiful thing, chat. It's a beautiful thing. You don't have to necessarily put in a shit ton of work. You don't have to learn about all the different fuse bits of a microcontroller in order to start using it. You can jump into coding very quickly. It's beautiful, and it's a beautiful thing to be spoiled rotten these days. It's wonderful, standing on the backs of giants, people who looked at the system and went, this sucks, and then they improved it. How many times have you beaten this boss? Not yet. I'm still out killing basic slimes to try to level up my gear. Once I do, I'll kill it in one hit, and I'll go, man, that was easy, and then I'll start posting about it on the internet, toxically. But yeah, I'm keeping it nice and clean here. I'm getting power from one rail, ground from the other. And I got it in and out on each of these. Now the question is, it might not be too advisable to power this whole thing up at once, because there's going to be inevitable errors in the circuits that I've built. I'm fairly lucky with that. I won't say lucky, I'm fairly skilled with that, in that I don't have, like, I've had a record of having stuff work the first time, but I don't know if I can live up to that record today, because I built these in a bit of a rush and I was a little tired. So, a 4-bit microcontroller from the 80s? Oh man, you gotta learn all that machine code? That was, I mean, like, we did 8-bit in college, and I had to, on pen and paper, run ones and zeros through instruction registers. So we'd go to the back of the data sheet, look up the instruction for, like, you know, move LW 40. And we're like, oh, it's row 40. All right, move this. Oh, that's going into the math processor. That was a horrible, 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 horrible test. You don't take your level 100 character base to the starter area just to test what the highest damage crits can do. That's right. That's right. Dex build? Ugh. All right, so that's power to everybody. The power is being supplied through phantom power, which is on my Focusrite 2i2. So if I fuck this up badly enough, then I don't have a Focusrite 2i2, and I don't have a spare. So I will be forced to plug the lav mic into the mixer in order to tell you guys that I'm rage quitting for a week or two. So if I mess up badly enough, my whole stream could go away. I don't think that's going to be the case here today, but you know, just fair warning to you guys. So let's see. Let's first of all, let's get that out of there. I hooked this back up, didn't I? I plugged this back in so that audio could go through it. I'm just looking around at what the various connections are here. What is you? What is this one? Just a random wire. There's like random wires sitting in this at this point. So we have our scope probes in. Let's go there. This is not necessary. This would be the virtual ground. That's going over here. We don't need the virtual ground apparently for the circuit. Although we might have to use the virtual ground as ground. Hold on, so this doesn't have any evidence of a virtual ground being used. It has ground and then power to the amps, but those are still running in AC. So it may stand to reason that they need virtual ground, and then these get power and ground. That might be the case. In which case, I'm going to have to reinvent how those little circuits are put together. Ah, crap. That might be the case. I might have to send virtual ground to these circuits, and then I may have to send our earth ground to the op amp, and then our power to the op amp, and then the op amp operates in that range. I actually think that's what we need to do. That's only 3 connections though. We can just sever 3 connections, and then I can just add them in. Damn it. All right, that changes everything. I wasn't thinking. Basically, this is an analog audio circuit. It operates in AC, so it's got plus and minus, but we're in a DC environment. Our power coming in is 10 volts DC. So we have an offset of about 5 that exists as our quote-unquote ground. And that ground is between the 2 rails. Our rails happen to be 0 and 10 volts, but in this case, it's plus minus 5 volts, because that's just, everything's relative to where you're measuring it off of. So my ground rail here, I think what I need to do, can't exactly make this as efficient as I would like to. Hold on, wait a sec. I mean, what I'd love to do is just sever the connection to one side, because what I did is I ran ground along the entire bottom of this thing. But if I take that pin right there and I isolate it, I just put it on a wire that goes out to the side, then we could achieve that grounding. I didn't think about this before. This is unfortunate. Darn it, darn it, darn it, darn it, darn it. Because yeah, we're not gonna get like a differential here if I don't do that. I think on this circuit it's a wire that's bent to the side. Man, that one looks a lot cleaner than the other ones. Oh yeah, it's because I ran out of this type of board. This type of board, all the connections are a little bit more separated from one another. It looks a little cleaner. Whereas this type of board, they're very close to one another, so everything looks like total chaos. So yeah, what I need to do is just sever that connection right there. I could just do that with a knife, or I could desolder it, and then I need, I guess I need a jumper wire to come off of this thing. Damn it. I wanted it to be a little cleaner than this. Whatever gets us to the goal, right? Death Soul. Thank you for the sub. Appreciate that. Let's go a long way around here. So what I could do is cut off the ground from one of these sides and then run a wire over to it. And I think what I'll do is I'll sever one of the sides. And bend that off of there. Oh, that was only a tiny little jumper anyway. And now I can take a black wire and I can run all the way over to there for my quote-unquote ground, which is virtual ground. You gotta keep this in context, because this is an audio circuit, and that ground level is the middle of the 2 potentials, and the opamp can operate at the two potentials. So the opamp is the one that needs to get, oh, that means I probably should have severed this one, huh? Because that's our zero ground, and then our virtual ground is going to have to run. Okay, all right. It's okay. We can do this. We can do this because this one is connected the same way. You're coming with me. Hello? Hey, what the hell? Come here. Come here, little wire. Get stuck to the soldering iron. Thank you. Come over here. So this is our zero potential ground, and then I'm going to make the other one. Ugh, that's the annoying part about this circuit. It's also why it produces very good audio, but you know how it is. All right, so let's get that pin over to that pin. So I'm just gonna strip it. A little bit of wire on the end of this thing. Okay, apparently somebody's doing woodwork in other parts of the house. They're pretty much just walking on top of this room. Somebody's dancing. Ooh, they dancing. All right, let's strip this back just a little bit. Don't need all that excess wire sticking out of the front of this thing. What's up, my edges? Doing analog audio stuff with a bit of a sloppy looking circuit, but it'll get the job done. What's going out to here? Well, we got to test it before I make a PCB, right? It's just like, I'm not just going to like dive in directly to making a PCB, because otherwise that modification that I just did would have been disastrous. Right? I would have had to sever trace lines. That's why we do this. We do this because these things garner testing. So we can nip these mistakes in the bud, and I can figure out what exactly I'm building. The goal for this eventually is to combine it with a Fusion 360 hardware design that I have of this thing sitting up here, this microphone pack, and so I can put all this circuitry inside of that. So I can have two of those that will be cleaning up and running my audio. By the way, guys, Julian is not going to be here this weekend. We had a scheduling conflict. It's just, you know, life came at him pretty hard, so we'll postpone. Tentatively, we're thinking about Saturday after this one in order to build his little circuit thing. And it's not going to be this kind of building. It'll be much easier, much cleaner building. Which amp? These are LF353s. Tree 5 tree. So I got to do this mod to all three of these boards, unfortunately. This is just going to take a minute. Take a minute, and then we can plug it in and see if it works. What it do? I found the LF353 to be A, one of the amps that I actually have, and B, I found the LF353 to have a sizable amount of gain that I could take advantage of. So what we're doing right now is we're severing the ground connection, because I took ground as ground for all of the audio circuitry. However, since this thing is analog, it uses plus and minus potentials when you boil it down. So the op-amp needs to have the full spread of that plus and minus potential in order to make the proper wibbly, wiggly audio signals. And then all the componentry that's going to ground needs to go to somewhere in the middle, which in our case is the virtual ground, what exists in the microphone circuit. So right now I am severing the ground connection to the chip, and I am moving it to a pin where I can isolate things. And that's why we build the circuit like this. That's why we build it so disorganized on a sloppy little board, because then we could make these modifications very easily. Now, that's not to say that you couldn't make this modification relatively easily on a PCB. You could probably, if you made a printed circuit board, you went through all the trouble, you waited a week, and you got all the stuff in, and then you found out that you needed to isolate your ground, there's a possibility, unless you ran traces in an irresponsible way, that you could just sever a trace and do this cleaner. But I'm doing it this way. Might as well. A little visual asthma. Soldering. That is hard to see. Hopefully there's no shorted connections in there. Glucometer beeped at me. Something's going on upstairs. I think there's like, I don't know. Somebody's rushing around. Maybe they're hiding drugs or something. It's like the most like militant fast walking that I've ever heard. Man alive, is it distracting. All right, so my best method for stripping the ends of these little wires is just to take the iron and just melt away a little bit of it, and then I can pinch it and strip it. Unless I can get a hand in there to hold the rest of the wire while I strip it. I need to find like a pair of hot tweezers. Some hot tweezers in my area. Or build them. Because yeah, people limbs are too clumsy for this kind of thing. And this is sort of like, I don't think it's really my method, but it's a method that I've picked up over the years of building test circuitry with surface mount and through-hole components, is you use single-sided perforated prototyping board with square pads, and those square pads allow a nice space for you to chuck all of your passive surface mount components. You have this nice little spot that you can chuck a resistor down. And then I use 30 gauge wire wrap wire. Strip board? Yeah. So there's somebody had me buy, and I bought too much of this other type of perf board that had this thing where you could bridge a connection in order to make your horizontal and vertical lines, but it just, I don't like that. And then the stuff like the track board, the ones with the like traces on them, I don't know. I just don't like them. I'd rather just use these wires to do it. Usually I'll relegate all the wiring to the underside. Works better with digital electronics. I was doing electrical work. The salty graybeard would use his lighter to melt the plastic and rip with his fingers. Yeah, I do the rip with the fingernail thing. It's not the best, but it works. That's not just a little wire section in these. It's actually a longer wire, so I'm just kind of doubling it back on itself. And then this is actually a wire that's bent into an L shape, but instead of trying to fully exfiltrate it, I'm just gonna hide it. Just hide it in the solder. No one will ever know. Yeah, they do. They definitely do have a use. The track board. And then people use software to like plan out like a whole circuit on one of those things, which, hey man, they're utilizing a lot of space and they're spreading out. At least they got that going. But yeah, this weirdo method is just something that I came up with. Not something I came up with. It's something that was sort of like partially taught and just sort of took into my what is it, my list of techniques, my Rar Doctor, says Ben Heck, has a fantasy where he'll get an implant in 2 of his teeth to bite and strip little wires. I stopped using my teeth. There's like a gap in my front teeth because of it. I guess I'll only use teeth on larger gauge wires. I'm not above doing that, but you know, you do it for a long time, and it does actually take a toll dentally. It's not a good idea. You can get the implant in your fingers to feel magnetic field lines, and then you get an implant in your teeth to strip wires. Can I get a soldering iron hand? All right, that. I'm just like melting it around, and then I can pinch it away. Really rudimentary. I don't like it. And yeah, I should have spread out with these things. I should have allowed myself a couple rows of holes, because that way I could have had the 10 kilo ohm gain thing in there without having to bend everything around in order to get it to work, which I will have to do. We're probably going to need it. I don't know what the gain situation is on these at the moment. Oh yeah, let's implant like a set of T-Rex helper hands, right? Little alligator clip hands. Edward Alligator clip hands. There's a movie. Get on that, Hollywood. All right, see, that's what this does. That's what it does when I heat it up and I have to pinch it. It ends up pinching away the wire, and I've just exposed my ground, which is not a big deal because it's not touching anything. But all right, so those are the virtual grounds. All right. Well, those are the zero potential grounds. Now I need to do a little jump to jump to jump thing in order to do the virtual grounds, which I'll just do with an orange wire. And then this yellow wire, which we got from over here, can come down and be our virtual ground. And I will cut off this circuit from power. We don't need power down here anymore. Ground is still connected, but the power line I need to sever so that we don't have excess current going into this thing. You're subject to whatever's already there, yeah. All right, so that's virtual ground. Oh, I need more holes in order to do this. You know what? Let's do that vertically then. We'll do that under the boards. I got to keep these in order because I didn't write down which one is which on them. Be nice to know which one is adjusting which. All right. So in order to run ground, our virtual ground, I'm going to run virtual ground over to here. I'll just jump vertically over to it. Now, what wire am I going to use? What length are these apart from one another? I got to go from 3 pins down from this thing to 3 pins down from this thing. All right, so that's probably another one of these gray wires, huh? So close. Well, actually, wait, that is right. It is it's the blue wire. So this row is taken up by the actual thing, but this would be the ground here. And then that is exactly the right length. Perfect. So yeah, blue wires it is. That is what I will use. That is it. That is the wire that I will use. So from there down to here. I'm not looking at chat. I assume I got a 5,000 person raid from some like famous person who's actually making a career on Twitch. No, it didn't happen. All right. All right, so virtual ground. I'm going to pull that up just a little bit so that I can access it. I'll use a turquoise wire. Turquoise wire is too large. Too large. Needs to be smaller. Smaller wire. Maybe a yellow. That'll move our virtual ground right to there. So let me get that out of the way. All right, so that's our virtual ground. We got our real ground. We got our real power. Now for the audio signal. But the question is, should I power these up and then just see if they explode? Or what the hell happens when I just give them power? Just power. I wager they're going to work. I don't have any reason to think that they wouldn't. Unless I plug them in upside down. Which I didn't. So yeah, let's get them plugged in. And let's just see what happens. They're not going to run any audio signal. They're just going to be existing on the same power as everything else. So I've got audio currently hooked up to an output here. If I move the resistors down one pin, will cut off audio, and then we can put it on the scope. I mean, we can put it on the scope too right now, because it's actually fun to watch all the audio signals rattling around. And then push comes to shove, we'll have to get in there and start troubleshooting. So let me partially clean up the desk, so at least we've got some free space to exist in. Get all this garbage. I need to just scooch over while the scope boots up. And then I also have my frequency generator hooked up to it as well. That's actually pretty good. We can live with that. You guys have no confidence in my abilities, do you? Maybe you guys have not been around for very long, but I don't make mistakes. I don't ever make mistakes. Eeny, meeny, miny, bingo. Yeah, I think I could just plug into this thing. Let's just get this rolling. So we got our 2 audio lines there. I'm going to unplug from mine. Actually, I could plug in on the second channel if I really want to. Now, I'm just going to fully unplug mine. Cordial Cephalopod, thank you for the gift subs, man. 5 of them. I appreciate that, Cordial Cephalopod. 5 gift subs. Man, they really made gift subs look ugly these days. It's like a bunch of big, giant fucking hearts in the... Anyway, thank you so much. All those names are actually going to go on a different list that's going to end up on the board. This is my laser etching, wall-mounted, sub-etching board. We're working on these things, right? We're working on this thing. I'm gonna get to that. We were supposed to do Fusion 360 today, but this audio stuff has me a little bit more engaged. So this is a live edge piece of wood. And so what we're doing with this is I'm gonna finish up that axis cart, which is what we would have been working on today. We may work on that tomorrow. I don't know. Once I get that 3D printed, all of our mechanical stuff will be quote unquote done on this thing, right? And so what I'll be able to do is populate 2 lists for when I'm done mapping the masking area of this board. And this board is going to have a fixed font size that will be different for subs and gift subs. So that's what we're going to do. We're going to do subs will be in a slightly larger bubble font, and then gift subs will be in a slightly smaller single line font, so they're differentiable from one another. And all the work that I put a whole freaking day into vector lines and making sure that single line font worked properly. So I still want to use it. It's all going to be Avener. It's all going to be single and bubble font, and all those names will go up in random places that don't hit the live edge. So that's going to be fewer names on this board. This much more expensive board that I bought. I hope I don't have to go back to this guy and buy another board from him, because then I have to have all the awkward questions of like, what are you doing with it? And like, do like an internet show. Oh, what do you do on the internet? I teach people to program. I'm like, yeah, but they can spend $5 to put their name on the board. Hey, Pseudo Memes, thank you for subbing. Was that part of the gift sub? Are we still going through that? Yeah, we are. Derek G-Man followed, though. It's pretty cool. Yeah, thank you guys for the resubs and everything, and the 5 gift subs. That's awesome. Anyway, let's plug this thing in. Let's plug this thing in and let's see what happens. So we'll go back to here, and I gotta mute, and then I'll plug in through this. You'll be able to see my audio there. You'll hear me just fine. We haven't plugged into the new circuit ports yet. We haven't done anything with this. We are literally just powering it. And so while we're doing that, it helps to have a thermal camera. This is like the one thing that I have. This is the one thing that I have that gives me an advantage over normal streamers, is that I have a thermal imager. It's a Lepton 3.5 in a Group Gets webcam module that I've designed a little 3D imprinted enclosure around, because this is the second thermal camera that I've owned. I still have the other thermal camera. The problem is the lens has trouble getting in front of the objective. It's got a little gate that it puts in front of the camera, and that little gate calibrates it, because otherwise it tends to like little areas that have like minute temperature changes tend to run away, and the whole thermal image becomes tainted. And so periodically what it'll do is just close the little plastic lid, calibrate itself, open it up again. That wasn't happening with the old one. New one, 3D printed enclosure, it's going to get damaged a lot less. What would happen is I would bump into that camera and the camera would loosen itself and then fall out. So anyway, we have a thermal camera. So the thermal camera helps us see stuff in electronics. You see, with electronics, and I don't mean to go on too much of a tangent here, but this is important to know. Why would you have a thermal camera? I get asked that freaking question like every day. Every day I stream. Why would you do this, bother? Why do you exist? What's your problem? Stop fucking existing, you stupid streamer. Why? Anyway, those are the kinds of questions that you get when you stream. But I constantly get asked why I have a thermal camera. It doesn't matter why I have a thermal camera. It's fucking cool, right? But an actual purpose of the thermal camera is to see heat. What we're doing is we're seeing heat in electronics. And when electronics fail, oftentimes, I'm not going to say every time, oftentimes it is due to a runaway current. And the runaway current will find any little bit of resistance, and it will use that resistance to create heat. And that heat kills electronics. So what we're looking for in this, when I power it up and I just give it power, there's nothing else happening with the filtration stuff. The op-amps are getting powered. They're getting whatever random noise is kicking around and doing, we don't care to it. We're looking for the heat to see whether or not there are any horrible, disastrous shorts existing within the circuit. All right, so anyway, let's hook it up. All right, you guys should be able to hear me now. Yep, there we go. So you guys are listening to me right now through this circuit, and we are also powering the op-amps. Now the op-amps are slightly visible, but you have to know that metal, in the presence of thermal imaging, metal reflects heat. Are these getting actually? That's just from my hand holding it. All right, I'm looking at the thermal from my holding stuff. I'm being like, oh no, it's heating up. Whereas it's not. Everything's looking pretty good. The one thing we know is that these transistors are working pretty hard. These transistors are working pretty hard. And that's true of the circuit board of this circuit that I built for the mic pack. So the mic pack has that circuit in it using curved traces and all surface mount components, and it's on one side. So that's what's powering this box right now, right? That's what's in here. Even on this one, those transistors, they show a little bit of warmth. Now, components getting warm is not a big deal. These thermal imagers will fool you. They will fool you. You will think that something is frickin' on fire. But the fact of the matter is, whatever this thing sees, it's auto-ranging. It changes the range of temperatures that it shows you and fits it to the palette. Actually, this is a copyrighted palette. This is called the lepton palette. The yellow, orange to, purples and blues. I haven't been able to get into the programming of the actual thermal webcam unit. I would like that. I would like to be able to turn it into an overlay with a keyed color. I haven't been able to get into that. You probably need different software. The information is there. I probably would need to run like a processing sketch or something like that. I would like to do that. It's just the complexity of programming something like that is kind of a little bit beyond the scope of what I do here. And I know Dewey compiled the software. I didn't want to mess with the drivers for the webcam module. Give a signal generator. These guys, come on. Okay, so nothing's on fire. Now this right here, this little connection, and that's how we build the circuit. So what I need to of ohm. All right, so I'm gonna cut my audio. Actually, first we need to do the routing in here. Let's do the routing down here, and then we'll. I can't move very far from the desk today. I gotta scooch in. Kids, scooch with the scooching. Kids, scooch closer. Gotta be careful because like this is my lavalier right here. So I am now trapped. I'm trapped. All right, so let's filter the low frequencies first. Should we just incorporate one filter at a time? Let's do that. Let's do one filter at a time and see what I sound like. I don't have feedback. I don't have headphones on. So I don't know what I'm gonna sound like. We'll just do this. We'll do this in a weird way just for fun. Let's get some jumpers here. I use these jumpers when it's like interconnects on the board and stuff. So using these jumpers, I know that, you know, a major area is connected to a major area on the board. Let's see. Well, in order to properly give you guys these filters, this is gonna be weird. Well, I mean, first off is testing the functionality, right? But I do have to disable my normal ones in order to show you guys what this sounds like, unless we use the O-scope to do a fast Fourier transfer like we did last time. I need to turn this. Let's make that a little bit more evident here. Wait, channel 2 is at 50 millivolts. What am I even looking at in channel 2? Channel 2. These are looking at the same signal. Why are they all over the place? Oh, because it's not even plugged in. That's just getting, channel 2 is just getting interference. What the hell? There. There we go. All right, that's a little bit more consistent. So yeah, those aren't the, this is actually the output of the amplifier circuit, and then it's also being input into the inverter part of the circuit. Yellow trace is so much cleaner. Okay. Orbatos, thank you for following. Orbatos. All right. These are powered. Nothing is exploding. Let's put the output. Well, if we do, let's do a mid cut. Let's do a mid cut because it'll be more evident what's going on, and we'll see if we can push past to the filters that I've already got. Because I want to keep you guys on the compressor because I don't want to blast out all your audio, right? I don't want to totally blast everybody out. I mean, we're going through this compressor already. I just want to verify the functionality of my circuits. Okay. So if we choose like a mid filter, and we'll see if you guys can hear anything. So the mid filter, where's that going to be located? That would be, let's do like 1K. 1K is a pretty, that's a pretty decent one, right? So 1,000 hertz, that's this one right here. So I have this page in notes. This one right here. And we'll see what the gain is like through that. Now technically, we should only be able to hear within the range of 1,000 hertz. So that's going to be a little weird. But we'll see what we get. I mean, it's going to, you know, obviously it's a bell curve. So, so our output is on this pin. Oh, wait, that's all the way up by the filter. Output is, so that's virtual ground. This one is output. And the one above it is input. I'll just color code these like I have the wires on the board. That one's input. And then we can sever the connection, chat. Get ready for some popping, by the way. Yeah, so nothing coming out of that. No output. I wonder if that's a gain issue or something else, because we didn't see it. We didn't see an output. I saw the yellow wire, which is on the input. Oh yeah, in and out are mixed. You're right. Input, output, input goes, output goes to the blue. No, I had them plugged in correctly. All right, let's try a different filter. Get ready for pops. You guys are gonna hear pops. It's just the reality of what we're doing, all right? One of the problems might be inverting. I think I need 2 filters. Otherwise, you need to invert the input. But I don't think inverting should do that much. I mean, if it is inverted, then it would just come out of the audio system inverted, and then it would go into the audio system inverted. So there's something else is wrong. Something else is wrong. Something else is not happening here. I don't know what though. I mean, if I do 2 of the circuits, then we do a little bypass here. And so I go from the output of 1, we'll go in the mid-range here, output of 1 into the input of the other, which is here. Assuming that I've got everything connected properly. Yeah, seems right. And then we take our output, get ready for the pop. Pop. Yeah, all right. So I was actually talking like I normally do. Yeah, percolate indeed. Now it could be a gain issue. It could be an issue of gain. What if I just carte blanche? What if I just hook them all up? It could also be an issue of my connections. I mean, I could just have a badly put together circuit. Output to input. Output to input. TX, RX to TX to RX to TX to RX, RX to TX, TX to RX. Wait a minute. What direction are we going in? Well, if I'm injecting audio, I kind of want it to go from low to high frequency. So if it goes low to high frequency, that means this one here. Well, that means that that's a crossover in a weird way. So, okay, we'll go high to low frequency. Take that there. Same thing here. Just make it nice and neat. Wow, what did that do to my regular audio? Seems to have... It's like jumping around. These are in AC mode, so I don't get to see that offset. There's a chance that offset's just in a bad place. I don't know. Well, also my audio isn't coming through like the compressor and stuff. We can only look at these waves in order to determine what's going on. That's not what I'm doing, Fadanon. No, sir. No, the dual gang, so the dual pots I have replaced with a singular resistor. This is what I'm adjusting. That would be the gain. Yeah. So what I did, and I explained this at the beginning, and it garners explaining again because we've like twice the amount of people. Is that what I did is I took the values from my digital filter that you're listening through right now. So the values of the digital filter I took, and then I figured out using a common capacitor and the equation supplied, F is equal to 1 over 2 pi RC, which is a common filter equation, actually. F is equal to 1 over 2 pi RC, which is what this circuit is doing. I figured out with a common capacitor what is the specific resistor value that I need. So I used the little Wolfram Alpha in order to do that equation. I probably could have used like a Google Docs spreadsheet to do that. I sometimes do that. You break down the polynomial in row by row, and then you can plug in values and it'll do it for you. But then, you think I need half? I don't think I need half. It's not, this isn't supposed to be like a center tap. I don't know. Hold on, one sec. So what I did, I took the polynomial and I used Wolfram Alpha and I replaced the variable in order to get a specific resistor value. I then went into my collection of resistors and I figured out which resistor represented which frequency. So we have a goal frequency, we have a standard capacitor value, and then we have a standard resistor value, and I was able to get good enough numbers out of it. And so that's what these are. And the reason I have them broken down like this is because they represent one side of each chip circuit. So those are the frequencies that I've got. So my derivation of this part of the circuit here stems from Elliot Sound Projects stuff. And in his circuit, let's see, there was a place where he broke it down. It's a wine bridge circuit. So it's this. This is the circuit. And that's what R1 and R2 are. I mean, I'm coming through this entire circuit, so there's potential for me to be very scratchy. I don't know. It could be like one wire is jiggled a little bit badly. I could unplug it and plug it back in, but I don't think that'll fix anything. It was better earlier. Okay, let me see here. If I'm still scratchy, it might just be because of this. But so yeah, this is the circuit, and these are the two resistors. So we got C1 and C2, R1 and R2, right like that. Yeah, the Focusrite wigs out a little bit when I do stuff like this. all the VST filters go psycho. But yeah, this is the amplifier circuit that I built, actually. Single band, wine bridge, tone control. I'm putting them all in now. They're probably not going to do anything, but I just want to see if maybe the effect of having them all in here is going to alter things a little bit. So my output is here, my input is here. Blue is the output. You guys are going to get pops here. Yellow is the input, blue is the output. I'm going through the whole thing. Here, wait. Let's give you guys like an artisanal view of what's going on. There you go. Well, now you can't really see the circuit. Not that the circuit's really the exciting thing to look at, but all right, let's see here. Input. Piss. So yeah, I don't know what the hell's going on here. The gain is just not working out for us. This thing might expect a much higher gain that it's getting, which I don't know how we can adjust around that. I mean, I'd have to look at some of the, I have to actually read the text. I'd have to do my homework in order to figure this out. Piss. I mean, we get higher gain when we add that 100K or the 10K resistor in there. R5 over here. But, I mean, I'm confident that everything is getting what it should. The other thing that could be affecting it would be my craftsmanship. I'm going to measure the voltage on the operational amplifier. I guess I could do that. I don't like to let chat tell me what to do. Ugh. Move to pre-differential amp. You mean, put this thing in there? I mean, like, in Elliot's, like, super-duper circuit, he's adding tons of op-amps. And the only reason this one's in there is to invert the audio signal so that it comes out uninverted. That's why I wanted to have 2 or, you know, an even number on that. But then there's this, which is not, he says, not necessary, and people won't normally hear that. So what's the potential across the op-amp? Now, it's supposed to be 10 volts across the op-amp. 10 volts across the op-amp, and that's the voltage of the rest of the audio circuit. And the fact that you guys are hearing me right now means that there is 10 volts across the op-amp. So from here to here. That's ohms. Okay, 5 volts. That's a significant decrease in potential. Oops, that's not on camera. 5 volts, it's supposed to be 10. I guess we're running into some of the limitations of the phantom power. What do we got going on here? Yeah, 5 volts. So if I cut these fully, we probably get our full potential again. I don't know what this is going to do. Sorry. Whatever that does to your audio. That's cutting off the virtual ground. 5.9. We're only barely at 6 volts. Got these. This is going to change my gain. Test 1, 2. Am I still... Yeah, it looks like I got higher frequencies coming out, too, because of the added power. Yeah, 9.6. All right, so they're a little power hungry, huh? They're a little bit power hungry. Chart. I might not have the power for the EQ circuit on the Phantom line, which is a little ludicrous to me, but that may justify digital filtration methods. I don't understand why, I mean, each op amp only takes up so much power. What if I just plug in one now? Still at 10 volts. We get the virtual ground on this. All right, we only lost so much. Now, my audio's still coming through. Good. Oh my God. Okay, so yeah, let's try going through that filter. All right. Ah, looks like we are actually getting audio out of here, although my gain is very low. I gotta talk a little louder to you guys while we figure this out, but my gain is a lot lower. This is a low cut right now. So let's actually put in the mid cut and see what happens. Because I am getting audio out of here. It's just the gain is severe. There's a severe lack of gain out of it. Yeah, maybe there's a short on one of them. That one is not. I'm sitting here going to get low and high frequencies into this thing. All right. Yeah. So that's partially our culprit is this middle one. Something is not happening in the middle one. Let me inspect that real quick. Do a little visual inspection because it's not dropping our voltage down. And then maybe the third has some kind of a short on it. So this is the culprit. Something's not happening in here. That is not connected right there. Although it is connected with a solder bridge, I think I need to solder this a little bit better. I'm going to tell you guys to stop backseating now. All right, let's get a little bit of solder in here. And I mean, it might just be that this connection is broken. Because I got a connection in there, and the output over here is good. That right there, that's good. That goes over to there. Those two connections. Like one of these could be hovering over the pin, possibly. That one's power. Oh, wait a minute. Oh, I forgot an entire connection on this one. Oh, that's what it is. There's supposed to be a connection from here to here. I forgot an entire thing. Yeah, I gotta get rid of an entire connection. Or sorry, I have to reinstate an entire connection. Do I have any blue wire kicking around the desk? I probably do. Probably don't have to cut off more blue wire. Yeah. I know more than you, chat. Let's move this to an area where it's not potentially being powered so that I can solder to it without, well, I'm still plugged into the audio that you guys are listening to too. That's kind of the weird part. That's a little bit of the weird part about what's going on right now. And then I got to move the microscope because I can't get the perforated board in the right position for this. All right, so that's not the right one. I'm going over here. And pluck this away. Now, hopefully this fixes it, you know, my whole setup, because it's not that complicated, you know? It should work. It's just a little sloppy. That's how we roll. Let's see if we can get these sufficiently out of the way, because I need to solder this, and then I need that to go here. There's probably a better way that I could have done this if I spread out more, but I was having a lot of creativity troubles in terms of getting this circuit together and getting it to function properly, you know, for my purposes. It could probably be a little shorter. No, I guess that's all right. All right, power, turn that on. Get it over here and get this soldered. I probably could have used a very large perforated board, perforated prototyping board, and just really spread everything out for the sake of research. And that's something that I got to get better at. That's actually something that I have to work on. Oops, my iron was off. Look at how quickly it heats up. Ta-da, ready to go. Because if I made this like really spread out, it would have been good. I mean, yeah, I can have the IR camera closer, but it's not really that functional. It's not necessary here. I mean, really, we were just using it to see if anything exploded. And nothing exploded. So that's way too long, isn't it? Well, I'm just going to deal with it. I'm going to deal with it. Bring that around and over to here and make shitty connection. Shitty connection. I don't know why we got such a big voltage drop, though. I don't know what that was about. Because it doesn't appear to be happening. Maybe when I get the final stages in there, it'll drop out, but cutters over here. My audio is still going through part of this perforated prototyping board. It's part of the fun of these streams is that I've got everything just sort of out here. I haven't done the bypass on my filters yet. I'm afraid to hit the buttons on the filters for fear that they will delete my settings. And if they do, I'll have to reinvent my settings. Luckily, there's a portion where I can just punch numbers in. So it's just a factor of my time being wasted. But like right now, I'm not listening to my output audio. If I were serious about this, I would also be listening to my output audio to try to replicate it. So I'd have a test phrase that I could say, and then as I repeat it, I would be able to determine whether or not I've had a good effect. Now that's still covered in plastic. What's going on here? What's going on here? I can just add solder to the end of it and that'll open it up. Ugh. Vsauce, Michael here. Where are your hands? I don't know, Vsauce. I don't know where my hands are. Give me my hands back. What did you do to me? All right, careful. Bend this into there. I did us the favor of powering down the circuit at the very least. I should cut off a little bit of that excess because it's right next to a ground. Right next to a ground. Can't see. I don't have parallax. That's going to be too much. No, there's still a little bit sticking out of the end there. Got like a scarf on. Okay, that'll be good. So yeah, our entire audio signal line is going in some weird directions here. If I really get a bug up my ass about this, I'll redo this on a larger piece of perforated board. If I can find what I did with my other perf board. Because yeah, on a larger piece of perf board, all this nonsense would be a little bit more managed. I just embrace the fact that this is going to be a large test circuit. So far, though, we did get some of the frequencies working. I don't know if we got enough gain on it yet, but we'll see. We'll see. All right, put all the soldering stuff away. We can reinstate this board. The other ones have that connection, right? Yeah, that one has it. That one has it. All right, let's try again. Bother, you didn't put in the potentiometer. Bother, what are you doing? All right, hold on. Put this out there. Put this back in where it was. Dad, hey Dad. All right, now we can put this filter into the mix. So I can actually probably put both of these in at once. So that would be the output. This is the input. Nope, that's ground. This is the input. This is power. Power it up on the 10 volts that we already have. Both of these. Sorry, this is not the most flattering view in the world. We're over here, I'm connecting stuff. It's probably not a good for microscope kind of view. Let's go up to here. This will give you guys a better view of what's going on. Now, my audio is coming out through here, and this is the raw audio. So this is before any filters. So I will run this block from this block, and then I'll plug. Now there's going to be popping noises, chat. So it's not the operational amplifier. There might be a short in one of them. 6.5 milliamps. Yeah, that's well within the spec of phantom power. Phantoma. Well within phantom power specifications. Here, let's keep an eye on our voltage while we do this. I'll plug these in up here. Good to have these high voltage scope probes can just plug into the the solderless breadboard. 7 volts? You gotta be kidding me. I'm losing 2 volts. Where's my power going? Any bad connections over here? It's possible. Oh yeah, I forgot. I can't change my position. Oh God. The position my position is in? I can't change my position because I'm plugged into this board right now. I'm plugged into this board. This semi-pro audio that you're hearing right now is thanks to these components up here. Brought to you by all this shit up here. Jeez, I can't move. Crap. I was going to try to get a closer look, but I can't. Now, if we go closer to the Zener diode, I might get better power reading. Yeah, see that? 9 volts. So it drops. I might have been plugged into something weird. Why would it drop to 7 up here? All right. The distance on a perforated, on a solderless breadboard can sometimes really get you. You know, the quality of the wires, the distance that you're running, and all that stuff will, it'll affect the voltages that you see. But for reconfigurability, second to none. All right, so plug this back in. Yeah, we're still dropping to 7 volts when I do that. Well, let's see what happens to the audio though. All right, popping noises, chat. Corday99, thank you for the sub. Appreciate that. Something still ain't work. What could it be? What could possibly be still plaguing this thing? So I plugged in on the bottom row there, and that one took it up and over. Oh, and I might have grounded it. Hold on. Oh, I can't get a closer look. I have to actually pick this thing up in order to get a closer look on it, or put it under the microscope, just because of the fact that I am plugged into the setup right now. The things I do for you, chat. The things I do for you. Let's take a look here. So I didn't correct this error over here. I don't know if that would be creating problems for us. It would mean that one of the filters doesn't get an input if that's not making a good connection. Here, come on over to where I can work. Oh, God. No pain, no gain. Get it? Do you get the joke? Hello? Hello? That actually looks like that's that looks like that's the problem. 0-bit error. Thank you for following. Yeah, that is. That's a cold solder connection. cold joint. You just get in there and fix that. If I don't melt everything around it first, that's the only problem. Oh, my finger is touching part of the board that's going to get hot. Oh, well. All it takes is a little solder, chat. Ow! Shit. Yeah, there's no connection there. It's gonna end up kind of getting a little weird, but owie. Oof, ouch, my bones. Ah, damn it. That went up instead of under. Okay. I just need to encourage it not to be a freaking fuckwad. Actually put this thing down like this. Stop messing with. Hold on, damn it. God, hands are cramping up as I do this. Yeah, see, that's all like caught in stuff that it's not supposed to be. That's what our cut was. That's why we didn't have anything. I gotta make sure that ground wire is separate. It's getting a little bit close for my comfort right there. And again, this is why you spread out when you build these things. I didn't, and now I'm paying dividends because of my transgressions against large test circuits. It's about to pop off. That. Okay. So now, now we actually have an input going into the filter. That's always nice to have. All the other connections look sloppy, but okay. Sloppy, but okay? Yeah. Slimy, but satisfying. Let's see here. That's going over there. That's going over there. You got that definitely connected. That is definitely connected. If I get frustrated enough at this, I will eventually rebuild it, but I don't want to waste any more resources. If I rebuild this again, I could just put it on a PCB. I could just make a test PCB for this. If it's important enough, I'm willing to spend the $25 to get a PCB shipped out, just so that it's a little bit more organized and I know what's connected where. The only issue with doing that is that you're committing to a circuit that you might be changing. You know, you might add additional connections and stuff. So maybe you want to plan for some of the additional connections, but when you set it in stone on a PCB design, you know, there's an issue with that. God fucking damn it. Corday 99 was a tier 2 for 48 months? Dude. Thank you. Corday 99, thank you so much. Look, man, that's huge. Capital U's. All right, so we're still at 7 volts, which sucks, although my probe slipped out, so there's that. Yeah, we're still at 7 volts after that correction, which, you know, there's only so many milliamps with phantom power, but it's hundreds of milliamps. So I don't know what could be causing that level of voltage drop across my circuit. It is a little bit concerning, and it might mean that something is a little bit badly connected. But anywho, let's take a listen here. So my voice is coming from here. I'm gonna put it in there, and then I'm gonna take it out at the top. mock, yeah, ing, yeah, bird, yeah, yeah, yeah. Okay, well, I get some audio out of this. So there's another error with that circuit. So let's take a look at it a little closer. It's still dropping the voltage down to 7. So sums up. Now, we have one functional filter here, and I could play around with it. We can see whether or not I'm actually, messing with stuff. Right now, the range of what we're working on is 21 hertz and 72 hertz. But it's also affecting the gain. So I don't know if do I try it? Do I try hitting the pass through? Bypass. If I'm bypassing the filter right now, how much different do I sound? Well, it looks like we're not picking up on a lot of the stuff that you don't normally do, but I'm unable to hear this, so I don't know what effect this is having on my voice. This probably sounds quite crazy to you guys. So if I get my screwdriver, wherever it may be, where's my screwdriver? Nobody's really commenting on how my voice sounds. I'm completely bypassing this filter right now, so things are kind of crazy. I don't have a lot of the gain where I should. What does the compressor look like? I'm not bypassing the compressor, so my lack of gain is showing. My gain should be somewhere around here. So what happens if I adjust the filter a little bit? It's weird though, because I'm not really going to be able to see the results of this. Where did my screwdriver go? Damn it. I'll get a different one. I'll get a different one. Check, check. 1, 2, 3. All right, so this should be the 73 hertz adjustment, and you should probably hear some kind of a difference, although I'm not really terribly certain that you would. Obviously, running the frequency generator into this thing is going to affect it in a big way, but as I adjust through the range here, you guys should probably be hearing some kind of a difference. I don't know. I can't exactly just make a 73 hertz noise that you could easily listen to. Overall gain, I don't know what to do about either. I don't know if I can get gain back by adjusting the some of the stuff and not the other. You got a gain change out of that? Yeah, it does look like the two signals are starting to match up with one another a little bit more. Because I mean, the combined gain of the various filters. There we go. Well, it's not quite where it was originally, though, right? If this direction is enhance it. Turn the gain up. It seems like I've lost a shitload of gain suddenly. Maybe because this wasn't plugged in all the way. No, it looks like I've lost a lot of gain. Let me go backwards a little bit on this one. Back on the other one. See if my gain comes back. La 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 la. I'm losing all my gain. Losing my gain. The gain's gone. My gain. My brand. Where is my gain? Hello, 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 hello. Hello and welcome to Alterations of Audio through Analog Electronics. Today, I will be your host in this wonderful world of things not quite working out the way that they should. Indeed, the gain on most of my circuit is gone, and I don't know why. Probably because I could use more of the filters on the circuit. More. Yeah, it is working. It's definitely working. Some of the frequencies are coming through a lot higher than the others. But I'm not getting back. All right. I don't know what this is going to do for you. Now I don't have any of my audio monitors. So if you guys can hear me at all, that's good. I'm probably a lot quieter than I normally am because I don't have anything to enhance the gain like the compressor does. But I can see some of my audio coming through here. It's just our mid-range like vocal frequencies aren't coming through. It sounds like I'm 10 feet from the mic. It probably would because this stuff is only working on the lower frequencies right now. So these are only the lower frequencies. So I only have so much low frequency in me at the moment. Yeah, it's hard. It's tough. Father walked into the other room. Hey, I'm still here. Hello, chat, help. Does anybody know a locksmith? I don't know. Help. All right. I got back that gain for like a split second. I don't know what happened. Pretty annoying because like I go in one direction, I go in the other, and the effect of this thing is varying. I could try to buttery biscuit base. I could try to run the higher frequency filter. All right, you're gonna get a pop here as I cut power to one of the filters and I try the one on the bottom. This would be the high frequency filters. Oh my God, my gain is back. I mean, it's all, what is happening? Check 1, 2. Yeah, see that? All the audio frequencies are coming through now because these aren't messing with my, they're not messing with my low end, they're messing with my high end. So what happens when I start messing around with this? Check 1, 2, 3, 4. These are significant audio frequencies. All right. Okay. All right. All right. All right. Okay. Yeah. Mock. Yeah. Ing. Yeah. Bird. Yeah. 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 These are messing with the higher frequencies. It got lower for a bit. It like, I think the potentiometer, knocked over into the next set of frequencies. So I'm looking at S's and stuff. It's not doing anything to them. Ah! Also, I totally bent that potentiometer. So I do not have headphones on. I can't hear what the differences in the audio filtration is. I'm going to have to plug in to headphones in order to listen to this. I mean, so far, like, it's going okay. I just don't know what effect this has. And I may have to put that 100 kilo ohm resistor on there so that I get the plus minus 12 dB of gain. So I get that extra, I get that excess of gain on the whole thing. It seems like a lot of the adjustment is going to be what I'm doing to the low frequencies. And then I, of course, really want very minor tuning on the high frequencies, but I don't know where the center position of the pot is. I guess I can measure it on this thing, the multimeter. All right, so compare that to this. This is completely unfettered audio from the microphone. No gain adjustment, nothing. You could probably hear scraping of, I mean, the effect was extremely dramatic when I first did this, so I think this probably sounds like ass. And now I've got all of my filters active again. How does that sound in comparison to the way that I was talking to you before? We're not going to see any difference in the wave, by the way, because the filters that I'm putting on are on the computer. Yeah. Bolder. Yeah, exactly. It brings out my voice a little bit better. It's a little bit more true to how you guys would sound me. How you would sound me. Please do not sound me. I'm not into that. No, yeah, it sounds more like you're actually sitting in the room. So, but yeah, so if I turn off the compressor, this is bypassing the compressor. So now you're just listening to my volume or to my audio through the equalizer. This is without the equalizer. So now you're just listening to my audio directly into the computer. This is with only the compressor. So now you're only listening to the effect of the compressor on my audio. And now you're listening to the whole ensemble. This is everything put together. And again, this is this circuit, which has some gain issues. There's a little bit of gain issues on this circuit. Yeah. That's the low end setup on the compressor. That's what this is. That's what this lump is right here. And I'm very particular about the smoothness of this transition down here into quiet audio going up into loud audio. That needs to be nice and smooth. But then this is all this lower end talking is boosted, and then it's lowered up here. So it's tough. I may need to do an equalizer circuit, and I don't know how to replicate that yet. But we're taking baby steps there. No, I've tried it with number 5 up a tiny bit, and that's higher frequencies, and I don't want it. Yeah, maybe it's a soft knee. I don't know. I don't know what it counts as. It's like my skateboard ramp. You can see that I've drawn out the Q quite a bit. I've got all those numbers, so if I can get those into, you know, I don't know what that even means. Feel in and out. Gain, output gain, release, RMS length, ratio, knee size. I have backup pictures of that thing though, because there's no other way to characterize these points. Unfortunately, I don't have like data on. It'd be nice if they do. Probably inside of the program, they probably have like, you know, they know what those numbers are, but they're not giving them to me, which is obnoxious. I could just look at the chart though. Yep. It's definitely not drums though. All right. So that middle filter is still cursed. So we got to take a look at that. Take a look at that middle filter. Where are we? We're over to the left. All right, so other areas that stuff could go wrong. Well, if that's not a good solder joint. No, that's a solder joint. It looks like hell, but it's a good solder joint. That's connected properly to this leg. Looks like it. Obviously, the multimeter will answer a lot of these questions, but oh, hello. Oh, hello. Oh, hello. Hello there, gap between capacitor and the wiper leg of the pot. Nice of you to participate. Or not participate, I guess is what's really going on here. I need to make a solder bridge right there. Well, that was definitive. That was definitive and easy to pinpoint. Man, a lot of this stuff was not plugged in at all. Alrighty, let's get in there. Know where my wrist is, know where the soldering iron is. Make sure I don't get in there and make a big hash of everything. Yes, good. Look, when in a storm, you know, all ports in a storm. That's a good enough connection for me to poop on. So I'll use that. Why was this thing dropping power to 7 volts though? I think a number of these things plugged into the same thing will just cause a drop, but that is connected to ground. Ground goes up through there. Ground. Good. All the way up to here where it hits the 7-volt virtual ground. And at that point, it should be cut off from regular ground. Make sure that that wire is separated a little bit to make sure that there's no unintentional jank. Oh, that looks like a short. No, wait, no. Nope. That is so close that I don't trust it. So let's do just like a screwdriver. Maybe the iron. Maybe a knife. Yeah, maybe a knife. Ganesh, where did it go? Where's my knife? Okay, maybe not a knife. Oh, there it is. I found it. That right there. Looking a little dodgy to me. Looking a little dodgy. Looking a bit like a Dex build. We'll just make sure that that doesn't make a connection. We don't even know if this is the problem. We don't even know. Yeah, it's been a long time since I've seen that film. ear did that thing come out? Crocodile Dundee. Now, is that making a connection too? That could be another problem right there. Just under this wire. Is it really 88? Oh my god. All right, so that one's severed. That's not making a connection. Let's see. Anything else? Everything else in this board is so sloppy. It's tough to. It's tough when you make something real sloppy. It's very difficult to troubleshoot. Very difficult. For the most part, things are looking okay. You know, if I were to do this again, might end up doing. I have to spread out significantly in order to get all of this stuff. Give everything room to breathe so that we can observe the circuit better. I wanted to get this done, and I started building it, and this is what I ended up with. So I duplicated it multiple times. Hello. But I think if I went a little bit more vertical with this, I could probably be okay. Hello. Capacitor, resistor, capacitor, resistor, ground. Potentiometer into capacitor. Yep. Other inverting input. So this is output, 2.7 kilo ohm feedback resistor, output into one side of the potentiometer. 2.7 kilo ohm feedback resistor, no connection here. No connection there. 2.7 kilo ohm resistor that goes back to the input on the other side of the pot. And then other inverting input goes around here to the other ladder. 2.7K, the pot only. Yeah. Pot only and not to ground or anything. Make sure that's not to ground. These little checks that you got to do. Looking good. Looking good, looking good, looking good. It could look better, but it looks good. Ground into earth ground. With a dodgy connection, but that's actually there. Dodgy, dodgy. Okay. Okay. Plug that back in. Let's try it again. These are the important ones. See, the problem is these are the ones that do all the mid-ranges. So they're going to have the biggest effect on my voice as you hear it. So that's why I want to get those working. Because, you know, for stream. Things unplugged from the power. Oh boy, it takes a little bit for everything to recover. And then let's check the voltage on everybody. 9.6. Good voltage. Don't mind it. Still 9.6. Audio's still coming through to you. Let's attach one filter to the next. So the output here going into the input here. I got to do this from so far away. This one is output. Curses. Curses. Something's still going on. All right. Well, I could put... I can't back away. I can't even, like, lean down to troubleshoot this thing because I'm plugged into it right now. But I can get myself out of the equation. I can cut audio. and we could see what a waveform looks like going into this thing. Thank God somebody suggested that in chat, or else I wouldn't know to do that. Sheesh. All right, yeah, let me cut myself off from this thing. So I'm gonna go back to my other mic pack so that we get good audio, and then we can hit this thing with various waves in order to see what's going on. So instead of looking at it through the lens of my voice going into the computer and then getting interpreted from there, I'll just keep my audio on me so that I can actually dictate what's going on. So I can dick-potato what's going on, and then we'll look at this circuit and we'll just give it a waveform. We'll give it a waveform within the range of the filter that we're adjusting, and then we can look at the output. So we kind of know what a good input and output should look like, right? I mean, if we look at my normal, slightly louder than talking voice, under the 50 millivolt range, we get a pretty decent idea of what everything looks like, right? So we'll pump a frequency in and look at the frequency out, and this can help us identify where our filter is broken, basically. Because that middle filter is the one that's really going to have the largest effect. You just got to pump. Yeah, just got to pump. Got to pump. You guys pump? You pumping? All right, yeah. Let's look at this. Man, it's tough to, like, I'm like self-conscious of my volume while I'm doing this. So it'll be good to remove that from this equation. All right, let me unsever my connection so I can get another soda. Just pumping and pumping. And it feels good when you're pumping. All right. See, the thing is, like, I'm doing all this stuff, man. You know, I'm desperately trying to get the circuit working, and I just need it to, like, so that I can plug into that other mixer. Because what I really want is... and I don't have to worry about them getting deleted by some random program. I don't know why I have such better gain from this one than the other one. I don't know what values are primarily different between the two. It might just be that this circuit is wrapped up much nicer. I don't think I have altering, like, resistance values or anything like that. We've got almost exactly 100 ohms on the outputs to those. So I don't know where all this gain's coming from. Maybe it's just the design of the thing. Getting it into a more compact space. All right, let me get a soda like I threatened to. Get soda. I'll beer. I'll be right back. I'm just going across the room. If you're not, chat, I'm just across the room. This is called intermittent fasting when you forget to eat lunch. I think it is. All right. Nah, not orange juice. I'm not low. That's actually worked out perfectly for my glucose levels. Look at that. Beautiful. And this thing will back off on the basal rate in order to keep that normal. So it means overall I'm getting less insulin, which could lead to a pretty bad situation where you go diabetic ketoacidosis, because the human body needs a little bit of insulin running in it in order to function properly. But I potentially could be getting very, 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 very little. That's why fasting is kind of dangerous for diabetics. That's why I'm not allowed to go on keto. And that is the only reason I'm fat. It's not. Let's see if we can get this voltage monitor handle a little differently. I think what I can do is put it on some of these headers, some of the DuPont headers, and then I can plug it into the board. Oh, sorry. Yeah, that's also Fatanon is actually the... I get it. I got it. Yep. Let's do these two wires for 10 volts. See, I made a bunch of these things, these DuPont to breadboard, and I never get a chance to use them. They're also good for the probes sometimes, because the probes can plug into the ends of the DuPont connectors. They kind of ruin them, though. So they're disposable items, but all these little tools that I should be making in the shop. One thing I would like to do is get another set of high voltage probe hats, and then I can cut these and turn them into prototyping board hats that'll have, you know, a little length of wire off of the end or something. But yeah, this should, without piercing my finger, son of a bitch. All right, I gotta go get that. There's like oh, I'm gonna use this, and I just drop it on the floor, and I go, happy birthday to the ground. Let's look at this one down here. Yeah. 892. Yeah, I don't know. I'm just not gonna, because the tools that I have and everything, I'm gonna go ahead and trust my doctor, random person on Twitch. I'm gonna go ahead and trust my doctor. All right, let's test to see that we get continuity on these. We do indeed. Perfect. Does that give you a doctorate? I think it does. Plus, you don't know my story. You don't know my care and management. No, but you know what? That does actually give me, like, he has a little bit of a leg up on the knowledge. I'll accept that. I'll accept that. Perfectly fine. You know, type 2 diabetic will know that the two conditions are a similar set of symptoms for different conditions. Okay, so like that, those are out of the way now. That's really all I wanted. Oh yeah, that's in the wrong mode. There we go. All right, so we don't have any power on this thing right now because I don't have anything wired up to it. What I'll do is I'll pull phantom power from the second channel of the Focusrite. So if I screw up enough with this thing, I can still take out all of my audio and peripherals from my entire stream, which is a bit of a harrowing position to be in. But we already have the function generator tuned up to do a sweep signal that's just about at the right level so that we can get sort of a replication of my audio going in. We can tune this to a specific frequency, and then we can look at what's happening with each individual filter. There's a bit of gain mismatch between all this stuff, so that's what we're going to be fighting during this. I mean, you guys could hear very plainly that there was a gain mismatch. These other Elliot Sound Projects, they're built for a big guitar amp, and that big guitar amp has plus minus 15 volts, and it's got all the gain in the world running from section to section. It's like, oh, I got a gain of 6 going from here to here. I don't have that advantage. We have barely 9 volts running on this thing. We have very little gain. We have very little current going into this. We have our virtual ground set up at like 7.5 volts for some unbeknownst fucking reason. It's all over the place. This is the Wild West out here, right? We got to figure out how we're going to make this work for us. And I haven't even bothered to figure out, you know, given the name of this channel and everything like that, I haven't even bothered to figure out what the gains are or how to adjust them. If I could adjust the gains, I would be a happy boy. It probably has something to do with the feedback resistors right here, though. So, but I haven't calculated anything, or I've read a bunch of the documentation, but I don't know. We're getting by so far. So, all right. So what I'm do is sever the resistor connection to the output. Now I need to keep the output plugged in or else I don't get power. Because remember, we're trying to design this all to function within the realm, within the limitations of phantom power, specifically the Focusrite 2i2's phantom power, which hopefully is very similarly spec'd to my mixer. Boy, oh boy, would there be egg on my face. We go through all this trouble and like the specs are different and so everything hurts. I don't know. No, I got diabetes from eating too many Twinkies. No, it's actually because my immune system attacked my own freaking organs. Little bastard. Talk about going above and beyond the Call of Duty. Leave my organs alone, you freaking whatever, T cells. Yeah, the beta cells and the islets of Larange or some shit like that. There could be a variety of factors that cause type 1. That are unknown. Come on. I don't want to launch this resistor across the room, but I will. Okay. All right, there. So that's the audio cut off. So now I can plug this into channel 2 without blowing everything up. Yeah, I don't know, the Langoliers or some shit like that. I don't remember. Go read a book. Yeah, I don't want to have batteries on this thing that I have to change, and I don't want to. It's, I don't know. Think through it, and you will come to my same conclusions. I don't want to have a wireless battery pack that I have to recharge. I don't want to spend money on batteries. I don't want to, like, fucking take you guys to the bathroom with me. All right. 9.5 volts. We're actually still plugged in on this one. Plug in another one of these guys. Yeah, there we dropped down to 7. Why is that? Is it just the amount of current that these things are using up? It's only like 65 milliamps. There should be plenty of power. Yeah, it looks like if I power more than one at once, all my current gets tanked. Son of a bitch. These require a couple hundred milliamps, don't they? Well, I guess I can see how much power these things require. All right, and then we go from positive here to, let's put this one over here. $3 milliamps? Are you kidding me? $3 milliamps. 3.5. 7 milliamps to power 2. 10.5 to power 3. Let's verify. Let's verify those specs though. Let's verify those. I mean, they're not running any audio right now, so it might be a little bit more than that. 3.9. So that one almost uses 4 whole milliamps. My God, 4 milliamps. What are we gonna do? I don't have audio to put through it right now. I could inject some of my sweep into it. See if that affects the number of milliamps. This is not plugged in. Signal generator. Oh, there comes the sweep. 3.8. Yeah, so that's not good. The audio coming through is not going to affect it in a very large way. So we got a frequency sweep going through this thing. We have 4 milliamps per circuit. And I got 3 of them. Oh, wait, I'm not running audio through it. Hold on. Let's run audio through it then. Blue trace is output. Yellow trace is input. So input there. Output. Oh, wait, that's not the one we're powering. Hold on. Let's go to the one we're powering. Input there. Output here. That's the same. It's the same amount of power. It's the onomatopoeia. I mean, the same amount of power. It doesn't appear to be doing anything to any of the frequencies. This one would be the high frequency filter, which should be coming in at 5.56 kilohertz and 20.095. But the gain is just about the same on the two, which is cool. That's pretty cool. Let me separate the channels out a little bit. On a digital scope, it's actually kind of difficult to see all the little nuances. That's tough for me to measure. I don't know how I'm going to be able to measure power from the main circuit. Not a lot. Not a lot. It's got one of the opamps, probably another 4 milliamps. So I'm just looking at this right now. I want to see if I can filter some stuff. Why do I keep losing the screwdriver? Okay, there it is. So we're looking for a drop off on the high frequency volume. This may not go high enough for this to get there. Sweep is sine, start is 10 hertz. I think the end was not quite where this thing affects it, which makes sense. So maybe we should hit it with 5.5 kilohertz and see if this one has a significant effect, or if something else is weird about my my filter design. Motion detected. Oh, look at that. Whoa! Now we're talking. Look at that. Ready? Bam! Look at that. Yeah, now we're talking. That's enhanced audio right there, if I ever done see it. That's what I'm talking about. That's 5.5 kilohertz audio boost. It goes away so quickly that I don't know if I can do anything about it. But yeah, you can definitely see that. And it's messing with oscilloscopes. Oh, it's always a good day when we get to mess with the O-scope. We can adjust the O-scope a little bit. Yeah, it's still using 3 milliamps, so. IEC standard gives 10. Project 93. I thought it was hundreds. Not 938. Come on. Ugh. Elliot. I'm gonna chase you off with a broom. All right. Phantom power. Electron mics, 1.5 volt cell. Blah, 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 blah. Control F and A. Will, may, performance, blah, 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 blah. Normally, many, makes, schematic, magnetic, amps, preamps, opamps. Getting enough current for the phantom supply mix is not a trivial task. 6.5 blah, 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 shortage of ground. The maximum available current is only 14 milliamps. With no voltage at all for workable current of, say, 10 milliamps, the maximum available power supply voltage is 14 volts. Getting the current as low as possible is a fine goal, but all op amps need some current to operate. But then when I look up, like, they're not going to give me current statistics on that, huh? Four milliamps at 48. Yeah, that's for this specific one, though. Yeah, so that could be the problem there, is that there's just not enough current. But I did find some other stats that were a little bit more generous with the amount of current available. Now, some of the stuff that was going on with this thing. Hold on, wait. Sound levels of 110, probably more. Sufficiently any microphones not used in close proximity, loud vocals or instruments. Although UNA shown with the gain of 2 can be reduced to unity by removing R8. Shorting R9 so that U1A is unity gain buffer. We don't want to reduce the gain. I don't want to reduce the gain. I've got lots of gain and it's very nice and rich. Now there's also a version of the circuit that doesn't use amps. of the mic driving circuit that doesn't use amps. It uses a lot of transistors in order to do the job that it needs to do. Supposedly Elliot prefers this one, but I'm not of a mind. I don't know if I appreciate this one as much. It's got ferrite beads on the two outputs. I got a couple ferrite beads sitting around. But yeah, I don't know if I'm willing to go over to a fully transistorized circuit just to make this amp work. I could reduce the number of filters that I put in my audio line, because I don't necessarily need them all to be there, but then I think I might not get my cuts properly. Although I don't know if I can implement this cut. I don't think that's really going to, you know, filter number 6 being all the way down there in the garbage may not come to fruition. But if I can get 1, 2, 3, 4, 5 would just be left to its own devices. I don't like that. I mean, 5 is barely there. 5 would be the one that we're looking at right now on the O-scope. 5407, which in our case is 5500. That one actually does have a significant effect on my voice, so that's how I'm getting the higher tones into you guys. I don't know, I'll have to play around. Well, we know the 5 kilohertz one works because we're able to enhance it. If I go into my frequency generator over here, my little dinky frequency generator that barely works, and I do not a sweep. No, let's get out of sweep. Damn it. Sorry, I was looking at the O-scope. Yeah, that is just about right. Mode. Select mode. Continuous wave. Servo position, sweep. Yeah, continuous wave. Hello? Selected. Oh, it's doing continuous wave right now. All right. Frequency. Amp? Why is this like stuck? Oh, there we go. I had to mode again. So 2000 hertz sine. Let's turn that into 5500 sine wave. 1 volt peak, or 0.1 volt peak to peak. 5 millivolt. That puts us right in the middle of the gain of where whatever. It gives us the replication of the audio that comes out of the thing. So yeah, from here I can then adjust the potentiometer. We can see what effect this thing has. This should lower it. It's not lowering it. Yes, it is. Look at that. Look at all that gain that we got access to. Now, am I able to go quieter than the output? I'm not. Yeah, so this is our minimum amount of gain. Most of what I'm doing is lowering the gain on stuff. Now, we're supposed to have 0.47 gain out of this thing. So, no, wait, that's Q. 1.41 dB of gain. What does that equate to in volts, though? I don't know how that equates to volts. Because, I mean, we can measure volts, so we can measure peak to peak here. I mean, gain is a ratio, right? So if we have... I'm going to see if we can measure this. If I can measure the frequencies out and then make the filter so that I've got things kind of where they need to be to give us kind of an initial calibration, right? So we need about 1.5 times what this thing is already at. So I'm going to horizontal my cursors, and I'm going to go from the peak of the wave to the trough of the wave. And the BYAY is 98 millivolts, right? So that's after our supposed gain. So let's move both of those as 1. Yeah, we're at something like 100. That's the wrong cursor. Something like 100 dB, right? Sorry, 100 dB. 170 millivolts. That's actually quite a bit. All right, 170 millivolts. So approximately 170 millivolts times, so it'd be 170 times 1.41 4, 1. Let's make that 1.5. So 255. I want to have 200. That's an interestingly binary number. I want to have 255 millivolts on this signal. So let me take both cursors, move them up, and let me make the div between the cursors 255 millivolts. Jesus Christ, this is a lot of gain. Let's take the other one, move it down. 246. Jesus Christ, I gotta make it span that? Do I have enough gain to do that? Well, let's find out. I don't know if it's linear like this. Is it really? I don't think gain is linear like this. I think it's logarithmic, right? I'm not sure. Gain to volt calculator, maybe? Yeah, you know what? This would be bad to do. Convert voltage gain loss to decibels. 1.5. Is it loss or is it gain? 1.5 dB gain. That doesn't make any sense. Wait, that's a voltage ratio. Oh, okay. Gain in decibel 1.5. 1.18 is the ratio. So then it would be 170 times 1.18, which is 200. We'll try that. So right now, I'm at 240. So let's take it down to 200. Take it down to the old school, because I'm an old fool. Who's so cool? Wait, that's positive and negative 74. When did it reset then? Weird. Okay, so I am taking it to 200. That's at 128. What the hell? Okay, cursor A, move you up. 48, 38, 45, 50, 80. Why did this all change? Wait a minute, why did this all change? I don't like what's going on here. EY and AY, and I should be seeing, this is 179 millivolts. Huh. Well, that's, okay. Damn, that is huge. That is huge. So somewhere around this range. 200 dB, that's loud enough to crack the planet. It's not 200 dB, it's 200 millivolts. 200 millivolts. I put it into a dB converter. It's 1.18 dB. Yeah, we're not taking out satellites of this thing. Getting to some real supervillain shit around here, huh? Adjusting, adjusting. Oh, slipped. Adjusting, adjusting, adjusting. These things have like 500 turns. I love these. Yeah, look at all that gain. No pain, no gain, chat. Yeah, Gonad has probably got a pretty significant shoe into being a supervillain, doesn't he? All right, done. Next frequency. Well, the next frequency is 20 kilohertz, and I don't even know if we're going to be able to implement that. That's the higher end of this filter, but this 20 kilohertz, I have it on a gain of negative 24, which just means we're lowering 20 kilohertz as much as possible. I don't know if this filter will do that. So, if I don't even know if I don't think this thing will do it. Let's put a fixed frequency of 20 kilohertz in here. 20,000 hertz. It's doing it. It's doing it. By God. So we want to lower this as much as possible. Let's see if we have any effect on it at all. Nothing, nothing, nothing. I actually think it's getting larger. Okay, righty-tighty, lefty-loosey. There we go. There's maximum 20 kilohertz. If you guys want to hear all of the high-frequency components of it. Okay, we're back. Let's never go that far again. I don't think we need thermals anymore here. Yeah, so you can see what I'm doing. I'm just... Oh man, that must sound awful. All right, so we're gonna go in the other direction there. Look at what it's able to do though. My only problem with this filter is that I'm not able to go lower than the input. It's not going any lower, and I need that to cut a little bit. I need it to pump. I mean, cut. I don't know if that's healthy, whatever I just did right there. I don't think that's a good idea. Yeah, that's taking everything out with it. That's just destroying all of our hard work. I don't know what that is, and I'm afraid of it. See, the 20 kilohertz comes back and then it cuts out again. So this filter might be totally useless, this one here. Unless I add the 100K resistor to this one. Get all the range back. Come on, man, stabilize a little bit for me. All right. My big problem with this is that I've run out of current for the filters. And I don't think that I'm going to be able to find a low current op amp that's going to perform like the LF353. That's my problem. I mean, we're like 4 milliamps per. 4 and 4 is 8, 12. 10 milliamps for everybody. I can only put one of the filters in because I've already got an LF353 over here running the show. So if I put 2 filters in, that's not going to give me the precision of adjustment that I need. The only other way that I could think to save that amount of current without getting real tricksy, with the circuit, is just to go digital. But I don't know what kind of current requirements there are for the other pieces of, you know, the digital apparatus. I don't know how much the D to A and the A to D is going to draw. So I've got milliamps left over when all is said and done on this microphone. Crazy stuff. Now, I honestly, like, I could go to the transistor based, the graphic equalizer circuit. That might be a way to do it. In which case I should probably put together a PCB with all that stuff on it, because that'll take less current to do its job. I don't know if I'm going to get the adjustment that I want out of it. But yeah, let's take a look at one of the other filters now. Let's try the mid-range filter. Well, the mid-range filter is the one that had troubles, so let's do the low frequency ones now. So we'll do 20 kilohertz and about 72. Although I'll have to go to my MS Paint drawings in order to figure out which one's which, and then I'll get the gain values from here. It's all references and cross-references and double-cross references and double-double crossing and triple crossing and double-triple crossing and triple-double reference crossing. So we're going 21 hertz and 72 hertz. Let's do this. So I plug this filter, go to the input over here, then I plug this output. That's actually the current, but that's going to move there, and I'll power that, and then I can move this one, put that one over there, I can move this one over here. And now we can see that it's drawing a total of lead. Wait, what? It's drawing point something milliamps. What's going on here? What is it? 0.9? That doesn't make no sense. 0.8? That's like nothing. What's going on here? Why are you drawing so little? What are you doing? What the dog doing? What the dog doing? Why is this drawing so little current? That's plugged in, that's plugged in, this is plugged in, that's plugged in, that's plugged in, that's plugged in, this is plugged in. Is it all on the right thing? Yeah, looks like it. Maybe this one just uses up a whole hell of a lot less current than the other one. Maybe it's using up a whole hell of a lot less current. I mean, it's not doing as much at the higher frequency. Let's lower the frequency to 21 hertz. Frequency. 21 hertz. Bam! We get a nice low wibbly wave. You can turn the horizontal like this and you guys can actually see. There it is. There's a lot of noise in there. I mean, 21 hertz is not a lot of frequency to be dealing with. 21 hertz was, I believe, a cut. So like, yeah, negative 0.26 dB of gain at this. That's not doing anything for us, so I could probably cut that one out too. That's 2 filters that I've gotten rid of already. It's below 60 hertz. It's not even a 60 hertz cut. 72 is doing more for the 60 hertz cut than anything else. So in that case, I just lower it as much as possible, which is already being done. We'll just test our filter to see how it works in this lower frequency. You know, maybe the values for capacitors and stuff that I chose have some influence on this. I mean, it's really like 0.1. That feels like it's not doing anything. I think lefty loosey makes it louder, right? Lefty louder. Well, it's not even activating on this frequency. Potential that there could be something wrong with the filter down here. Yeah, I could. Well, that's the thought for the next stage, or the stage before this, is a high on the low pass. High and low pass filter, and then we put it into 1 or 2 op amps in order to do the EQ. Yeah, okay, so nothing's going on with that. Let's bring it up to 72. What is our exact frequency? 72 hertz. So frequency 72 hertz. There we go. Man, it is not representing these very well in terms of gain. Let's take a look here. Let's just see if we can get that gain back. It's like a very, very noisy signal at this low frequency. Okay, that's the limit in one direction. Move in the other direction, and we get a little bit of definition out of this thing. Maybe I chose the values wrong on this one. Nope, here we go. We're getting some of the gain back. So at 72, I got the same 1.41 gain. So I need to make this wave fit in the same parameters. Look at how it suddenly kicks in. Oops, I slipped. Screwdriver slipped. Oh my god, it's so much louder. So there's our 1.41 gain, 1.5-ish. Another primary adjustment. So this one right here and that one right there are doing the most so far. And look at how much current we're drawing on that. What's that all about? Oh, AC milliamps. There we go. All right, never mind. Same amount. It's the multimeter flipped itself over to AC. Yeah, I don't know if I want to. I mean, yeah, I could do a little go-between box that gives me a little bit more phantom power. I don't know. I think maybe high pass, low pass, in as little current as possible, and then we'll see how many op amps we're left with. It's probably going to be 2 though. I'm probably going to need 2 or 3 or maybe 1 quad. Well, okay, so there's that one. Next would be the one that's giving us troubles. So there's that, and we'll move these over to it. And we can see definitively that whatever's going in is not coming out. Now, if we flip to another filter, if we flip to the 20 kilohertz filter, we should be able to see our low wave go in and out without being altered. We definitely don't. Okay, wait, there. Yeah, see, we see our wave going in and out without being altered, right? We shouldn't be touching frequencies that we're not tuned to. So when I put it into this one, and I take a look at the output on this one, the fact that there's nothing but noise there is a problem. So there is a problem with this one. It's drawing enough current, so our power and our ground are in there, but what the hell is happening elsewise? Let's take a look. So if I am so inclined, I can poke at this thing a little bit, see if we actually trigger any audio coming out of it. We'll just see what's what. Now I can actually, what I can do in the meantime is I can actually stand up and then get real close. I'm gonna lean real close into this because you guys may be able to see through the microscope, but I'm not seeing enough stuff in the microscope to help me. I need to get that 3-dimensional view going on here. mean, so far so good, right? We got a bunch of the filters to do stuff. I'm pretty excited about that. We got some results in our audio. How about you, Mr. Input? Are you actually inputting properly? That's the input from the rest of the circuit, and then the output is up here. Because we should be seeing this wave coming out of the circuit. It shouldn't be cutting it off anywhere. Whoa, careful. Careful, careful. We still got 10 volts on this thing, so I can still fry stuff if I'm not careful. Yeah, that's all well and good. Did I blow up the opamp or something? Blew up the amp. I don't know. I mean, I don't see any, like, severed connections or anything. And we're getting enough volts out of this thing that'll tell me that, like, this thing is connected to power. The only other thing that I could think of is if like, one of the IC pins aren't connected properly. And that's only introducing noise. Whoa, okay, sorry. You guys are lucky you're not plugged into this thing right now. You count your lucky stars. I do not know. I do not know. What is limiting you? Could it have been the values that I chose, like coming in to bite me in the ass? It should be at 0 potential, and then everything else should be at 7.2. Huh. Hum, hum, hum. What could be wrong with this? All right, let's unplug it and do another shakedown on it. Unplug it and do another shakedown. Oops, that's the wrong. Oh, you guys are looking at the wrong one. It's actually the one below it that I was working on. Sorry. That one's the one that works. This is the one that's giving us a major pain in the ass. Poopty poopty. Groovy something, thank you for subbing. Oh, I gotta move the overlay on this one. Let's see if I can grab it. Groovy something, thank you for the sub. Appreciate the poopty. That'd be 35 months of the tier 1. Dude, thank you so much. Thank you, thank you, thank you, thank you. I really do appreciate that, man. All right, so what the hell's going on? So we get audio through all the other filters, but this one is the one that's decided to give us gruff. So say what you will about my methodologies here, my methods of building stuff. So far, I got 2 out of 3 of these things to work. I just haven't had the opportunity to troubleshoot this one. Now, is there too much solder in there? That could be. That might be a problem. You're gonna seafoam it again? That's so much seafoam. Meetings. Well, the good thing about streaming is you don't have meetings. Although I have a feeling the more popular streamers do have meetings. They probably meet about stuff. They're all talking about, who's this fucking tech streamer that keeps watching my stream? Harshing my vibe. Sucks. Can't say anything about him. He's just like there. Yeah, this is the one that's giving us trouble, and it's still giving us trouble. Barely ran cold when I started it. Oh, God, that sucks. Are your neighbors at least tolerant of the sea foaming? Because that's always rough. They're not. No, I'm not talking about. Yeah, they don't care about normies. They don't care about a small fry down here in the trenches. Down here with the people. Automatic, just for my people. Well, so I mean, I don't know how much you've watched, but we have 2 other working modules like this. I've already got 2 other working modules like this, so just getting this module to work is the only, like, there's no troubleshooting for this. It's just get this to work. The other two modules, by the way, have component values that are tuning them. And I don't want to swap the components around because the way I built this sucks. And I should have built it a different way. But I didn't. I built it this way, and this way kind of sucks. And so it's hard to get to all the values and stuff. So what I'm doing right now is I'm doing a cursory check to figure out whether or not any of these lines have shorted to one another. Now, I could do this with a multimeter, but scraping it out a little bit is a time-honored tradition. This is not the typical proto board that I use. The proto board that I use has better spacing. It's got a little bit more spaces between this stuff. And that helps keep you from having to do this too much, this whole step. All right, let's do a little probing around to take a look at ohms at various locations on this thing. That's that Nick Offerman at Home Depot thing. I know more than you. Let me work. Let me work, everybody. I'll surprise you every now and then, and do something that you think that I should do after you already think that I should do it. So we're not interested in the multimeter, in the scope right now. We're taking a look at the multimeter. I'm going to pull the probes off of the ends here, our power probes or amperage probes. Look at the staples or office max. Yeah. Let me put this over to ohms. Now, I use ohms. Some people use continuity. They are subhuman. They're not actually human. They are lizards in a skin suit. People who don't mind the beep. I mind the beep. We're working on an audio circuit. I mind beeps. I fucking hate beeps. Part of it is conditioning from owning an insulin pump for any given amount of time. Every single beep is important, and unfortunately, the way that Tandem programmed this fucking thing is that this is like grandma mode, which means that I can't get into any of the sort of finer settings of this thing in order to turn off all of the useless fucking alerts. After 2 hours of a high glucose level, it will panic remind me that I should check a blood glucose level when I haven't checked a blood glucose level in months because of this thing. This thing is amazing. It has the, what is it? The, hold on, brain fart. Yeah, that's the brain fart. This thing has the Dexcom G6 built into it. And the G6 doesn't need finger poking in order to get its calibration. Now, I've tested this a couple times by doing the finger poking, because you're conditioned as a diabetic to always need to be poking the fingers in order to get a good glucose reading. But it's been accurate every single time. So I haven't had to test a glucose level in a while by pricking my finger. Yeah. But the problem is, I was hyperglycemic for a split second, like 4 hours ago, and then it's going to beep at me with this incredible, just like alarm, beep, 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 like insane, to get me to test a glucose level when I'm not going to, because my glucose level is fine. That's the same beep it gives you when it's out of insulin, and the same beep it gives you when you're hyperglycemic. Both of those other cases are far more important. So over the years, I've become conditioned to absolutely fucking hate beeps. That's one reason why to use ohms. The other reason to use ohms is that ohms will give you more of a picture of what's going on in the circuit. So when I put a probe on one pin and I put a probe on another, I need to know what the resistance is from probe A to probe B. If I have it on the beeper mode, I'm not going to get that. I don't get a beep. And I won't know what's going on. I could be going through a high resistance. I could be going through microcontroller pins. I can tell with ohms. I can't tell with a beep. So that's why I use it this way. So yeah, people who use beeps are subhuman. Anyway, between here and here, should be somewhere on the order of 5K. Okay, well, let's test over here then. Between here and here, 5K. No? Oh, well, there's also audio running through that, so I gotta be careful. I feel like I should see resistance there. Oh, wait. Remember thy leads. Gotta flip them over. This should be going through the entire potentiometer. 4.5. Now, what do we think of 4.5K? Well, looking at the circuit, plop. Looking at the circuit, if I'm going from input to output, which is here to here. By the way, I don't have a 100 kilo ohm to ground. I don't think that's going to do anything for us. But if I go from here to here, we're looking at the entirety of a 10 kilo ohm potentiometer, weighing it against that right there. So 2.7 times 2. 2.7 times 2. That resistor is 5.4 ohms. So we have 5.4K. 5.4 kilo ohms and then a 10 kilo ohm in parallel. So 1 over 10, 000 plus 1 over 5000. I didn't hit plus, I hit all the wrong buttons. Anyway, the point is that the parallel resistance of the two will probably come out to be about 5.5, maybe, whatever. Anyway, so that's within spec. Let's just probe around and just probe from point to point and just see whether or not we get stuff going on. I'll use this view because there's no chat. All right, and then you guys can see what I'm probing as I probe. 3.5K. Well, you know there's some issue with the output. That makes a connection. It's pin 7. That's correct. So yeah, I should be seeing, hold on if I can get that properly. Yeah, that output's good. Input. Where does that input go? It goes through a 2.7. So 2.2. About right. The inverting input doesn't really have much to do with it. We get mega ohms. We get inverting input on power, inverting input on ground. 1.6K to, where does that one go? That one goes to, that's 0 ground. No, that's virtual ground. Virtual ground, that goes through other parts of the circuit, although we're not plugged into it. The virtual ground, 10K, 10K. Yeah, it's gonna be some. That's gonna be some such value. Yeah, well, there's other stuff going on in the circuit, so it's not just going through that resistor to get there. But yeah, I mean, it's possible that the resistors are off by that much. But I think that's good for the input on that one. Let's check output of this one coming out of here. Ohms, good. This one, 2.7-ish. 7. 4, 5. Where are we getting 7 from? Probably the adjustment. Because, yeah, that's ground. That only goes here. Above it, we have a short to ground. Aha! There we go. There's a problem. There it is. There's 4K. There's your warp bubble, Wesley. 4K on both of these? Is that all right? I don't think that's all right. I don't think that's all right. These feel like they're shorted together. Ooh, what is that? That doesn't feel right. Yes, it does. I was talking about that earlier. Basically, people telling me I should be measuring each component, and you know what? A lot of this circuit is just flying by the seat of our pants. So I'm not going to sit here and measure every component. If you really wanted to be the coolest kid ever, that's just so much fun at parties, you could sit there and you could measure out all your components. I'm going to put a very fine tip on the soldering iron. You could sit there and you could measure out all your components and derive all the statistical variances between them and make sure that everything is exactly correct. And, you know, you'd make a good analog circuit for that. But I don't care.
I don't care. We're dealing in sort of maybes, especially when it comes to sound. So that I'm not going to get all crazy precision with this. Now, were I building this on a PCB, I'd consider getting precision components, but I think we'll be okay. You know, I'm not, I traditionally, I have not ordered precision components for everything. Yeah, these are shorted to one another. There's some sinister shit going on in here. So you just bend that away a little bit. Does XOR. Thank you for following. Oh, God. Hell no. I'm not, I can't. Ooh, melted the shit out of that. It'll still function, I think. As are distracting me to the point where I'm getting all this stuff cross freaking wired. The problem is I can barely see into there to see if there's solder down there that I need to get rid of. Because I think what I'm doing is I'm poking through to the hole and misinterpreting that. So let me just do a little continuity on that. Man, okay, let's clean off the side of the soldering iron to make sure I don't have burning plastic. This is why we run a fan. All right, so we need to find, I need to find like a different junction for each of these. So if I go here without shorting the ground, so I'll go up a little bit. There to here. I should not see continuity. 7K. I don't know what that is. I don't know why there's 7K between the legs of this thing. Because it has to do with the values that I chose for the filter. Ground, this ground, to this pin. Okay, good amount of resistance. And this pin to this pin. All right, I'm gonna try to test it. Let's see what we get. So the oscope is still hooked up. I just don't have power to the circuit individually. I could put it back in the current testing mode, or I could just plug it in. Is that correct? Yeah. All right, and then I give it power. Fucking nothing. Damn it. Son of a bitch. That's this one right here. So for some reason, we got nothing going through this. It's destroying our wave. Our wave should be going through there marginally untouched. I mean, we're not, what are we at? We're at 72 hertz. So yeah, our wave should not be altered by this. So let me see here. Make sure that everything's plugged in properly. That's always a good check to do. Wiggle some wires, poke on some stuff. Nothing. Nothing. All right. So what other reason would there be for my circuit not working? I'm going to pull this out again. Take a look at it over here again. Let's see what we got. Let's see what we got. Hold on, I'm going to get to the right microscope view. All right. Microscope. Pop. Not that one. We'll do the full. Just the nope. That's not the right one. Full micro. Did I get crackly? What? I didn't do anything. Hold on. All right. Hold on. How about that? That's so weird that happens, and I wish I could figure out what that is and somehow, like, do something against that. But I mean, it's only a slightly more organized version of this circuit that I'm running on this mic. I don't think it's like a short in the line or anything. I think it's just the audio system getting a little buggy. I think these two are shorted together. I think that's what I'm seeing right here. I think that's what this is. Where's a pointing device? Here's a big scary pointing device. What I'm seeing there is okay, pointing over here. Okay, fuck, okay, pointing over, ow. Okay, pointing, okay, so if I point right, oh my god. Anyway, right here, it looks like there's a bit of a solder bridge. Yeah, know your tools and how to use them, all right? Don't do what I do at home. These look like they're probably solder bridged together, but I can't really prove it in a court of law. Those are definitely solder bridged together. Looking at them again, it looks like there's a giant solder blob right there. Hold on a minute. Hold on a minute. Let's get rid of that. Let's suck some of the solder out of there so that I can work. I don't know if this iron's going to really do it. This iron's not good for solder braid. Well, we'll have to try it. We'll have to try it. Actually, let me cut a little bit off of the end of this stuff so I have a nice working end of the desoldering braid. Of course, this thing is altering my light. Well, let's replace this with a different one that's not melted. I'm trying to just get in right here, so. Gimme. Neighbor's dog is barking. What you barking at, Millie? All right, a little slow to pick up there. Maybe I can actually see what's going on now. Can we get closer with the microscope? No, not without me lowering it. And I can lower it, but you guys will be like face down in all of my garbage. Here we go. Face down in the garbage. That's where we are. Here's my absolutely disgusting circuit close up. That is most definitely a solder. No solder bridge. There's no solder bridge there. But that one wire is now disconnected thanks to solder sucking. So I'm going to make sure that this thing, here, let's get this out of the way. Hold up. Let me just plug this in so that it stays still. You stay right there. You come with me. Damn it. Man, these things can really hold on to components, huh? All right, so let me drop my new mix single. I mean, a little bit of solder onto this component here on the leg so that I have something for that wire to attach to. I don't see where the problem could be if not right here. And I don't know, something looks like, I mean, if I get that wire out of the way, first of all, move that out of the way. All right, so nobody's really connected where they shouldn't be. You know, the ground wire is avoiding that right there. And there's a lot of garbage, you know, kind of in the area, a lot of dust and garbage. That's sort of normal for this kind of circuit. Is that cut off properly? Yeah, there's nothing there. This up here. I probably should have used this tip the whole time, to be honest. Probably would have made a cleaner attempt. I'm just looking around right now just to see what I can see. All right, so this right here, it looks like there might be a little bit of a bridge under. Yeah, you see that? That just kind of like disappeared right there. There might have been a sneak. That might have been one of those sneaky little solder bridges that will drive you nuts. Will drive you crazy. Well, I don't see a lot of potential for solder bridging going on this circuit. Should have used the breakout boards. I could have built a whole thing. It would have been much more organized and easy to troubleshoot. Big old blob on there, and then we'll just drag this thing over to the big old blob. This horrible looking thing. Really is really bad, isn't it? It's really bad. But it don't matter much if it makes a connection. I almost touched my soldering iron. Yeah, well, that can't argue with that. That definitely makes a connection there. Are there any other areas that I would see like an issue with some connections running over on others? I mean, if we had a short from input to output, we would get good gain out of the thing, and we're just not getting anything out of the other end of the circuit. Reinix, thank you for following. We're not bridging our grounds together. We would have many more issues if that were the case. Yeah, moral of the story, this is what I've been saying all day today, is spread your circuits out, folks. Like, definitely take up a lot of space. I built this because I was having a bit of a creative block on designing stuff, and I just built it, right? I just built it and I went, there it is. Let's use that. And I think what's happening here is that I've not taken up enough space. I should have spread out a lot more, and then that would have given me an easier time vetting out all the connections in the way that I am right now. But at least you guys get to see this for once, because usually people are like answering all the questions for me and giving me all the answers all the time, and I hate that, because then you don't see this. This is a crucial part of creating electronics, is being able to vet out issues and troubleshoot them and figure out what's going on with your circuit. It can get very frustrating at times, but it is a very important skill to have. I don't see any problems with any piece of this, unless two of these are... Oh no. Oh no. Oh no, 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 no. Oh no. You guys see that? Oh no. All right, I'm gonna have to get a larger tip on this thing. Hold on, I gotta swap the iron tips. At least we know now that basically this is connected, and that tanked our whole circuit. Getting out a PCB etching kit for something like this is ludicrous. I mean, if you have a CNC machine, I guess you could take a copper-clad board and you could make a quick design and get that done in like an afternoon. Maybe. This would be like the only time that I would advocate something like that. You could also design a board and then take the tile etcher and scrape off all the places that you would need connections. But at that point, why not just use a perforated prototyping board, right? Why not just use the perf board to do it and just spread out a little bit more? There's no, I don't know, man. The speed of that kind of stuff is a little ridiculous. Like etching and things like that, totally pointless in this case. You know, and if I really wanted to throw all my eggs in a basket, I would make this design on a PCB, make a silk screen so that it looks like the circuit diagram, and then have that as a test board to add to the rest of my setup in perpetuity. You get 5 boards for $5, right? Love the look of fully debugged, dead-bugged circuits. Yeah, I'm not dead-bugging. The technique that I'm using is my own, I guess. Other people have probably come up with it, but the technique that I use is called live bugging. Because dead bugging is so freaking hard to figure out what pins go where. I hate it. I mean, I don't hate dead bugging. I've done it many times, and I've done it very successfully. What I've done is I have attached the ends of the SO8 to the perforated prototyping board, and I put a piece of Kapton tape in the middle that's blocking those 2 center pins. Dead bugging is when you flip the entire chip over and you glue it to the board, and then you can run wires to each of the individual pins. It's one of the OG ways to actually use surface mount components with perforated prototyping board. You see, the thing is, like, all the decisions, and you guys saw like last stream, I guess 3mares had to kind of set it straight with me, because I was like really worried about last stream, because the results from last stream were bad. You know, nothing good happened from last stream. I couldn't make decisions. I couldn't come up with techniques and stuff and stick with it. I kind of went through and looked at something and then I threw it out, you know, several times. I was pretty wasteful on parts, and I just couldn't I couldn't go forward with it. I I couldn't go forward with the design that I wanted to go forward with, and then we ended up like solderless breadboarding it, and we didn't even get a result, right? It was dumb. So it took Wednesday, and I sat down and I tried to get everything working exactly the way that I needed it to be working, and putting together these smaller filter circuits. And while this is a gateway to a world of hurt, for the most part, I got them working properly. Now, we got that giant solder bridge right there that we need to deal with right now. But it's tough. It's tough out there. It's like, what do you do? Do I wait a week? Do I put my design to like fruition, wait a week, and then get it in the mail, and then it's $5 for 5 boards, right? That is like a shortcut nowadays. That's totally spoiling everybody in terms of design. The way we used to do it was you would put your design on a napkin, and it was an actual napkin at a diner, and then you would put that to paper, and you'd refine it a little bit, and you'd figure out all the stuff you need. Then you'd take one of these Jim Jams, and you'd plug everything into this, where you could actually alter the circuit as you go and figure out exactly what values and components and structures you wanted to have in the thing you're designing. You could add filters, stuff like that on the fly. Then you would take one of these things, these little perforated prototyping boards, and you would build something a little bit more permanent. And that little more permanent nature of the thing you're building would allow you to vet out things in a more concrete manner. All the components were soldered in place, all of the wires were soldered in place, all the runs for the wires weren't going in a circuitous fashion around an entire big board, and you would vet that design until you had something that you knew worked. Then you'd go over to the things, the psychotic things like etching your own board or CNCing your own board. In my case, I would go to something like PCB 123, where it was basically like MS Paint for drawing circuit traces around. But that was the process. That was the sacred process of designing a circuit board. Nowadays, it is so cheap to have your own boards burnt, you know, at a professional manufacturer, that you might as well just do that. Why do you need to do? I mean, I could jump into putting the circuit together as a PCB, and then I can alter that PCB, because really, when you order a PCB, your first PCB design is not going to work. There's going to be all kinds of problems with it, right? And things that you want to improve. So your task when you get that first PCB is to absolutely, under all circumstances, all stops pulled out, get that thing to work. Get that to work. And then you take all those edits and you roll them into your files, and you get another print done. Yeah, nowadays you can get a 1-day turnaround on a board made in America and have it sent to have it fucking like put into a t-shirt cannon and fired up at your ass in the later that afternoon. That was never a thing. I still go to China for my boards, which means there's about a week of lead time. But if I gave them enough money, they would get the t-shirt cannon out for me. All right, so let me break the connection between these friggin' bins, huh? And then we can get the rest of this filter to work. Now the question is, oh fuck, how can I do this? I think I'm gonna have to get solder braid in there, and okay, I need to put it in a vise in order to get it at the right angle. Where is that? There it is. All right. And like technically when we're done, I'll have 99% of my actual audio filters ready to go. I just don't have the current to power them. So that means I'm not precisely sure what we're up to tomorrow. We'll figure something out. I always got stuff to do. We could do a Fusion 360 day tomorrow, which is what I planned for today, but I decided that I was too into this, and I wanted to make sure everything worked. I put too much work into it, and I wanted to show off all that work. All that work. Did I even do anything? That is a negative Ghost Rider. Well, it does look a little bit different. There's a massive solder bridge under this, but there's all this meltable stuff around. Yeah, I gotta finish that 3D design, and so I've just gotta. It's like I won't work on it unless I stream it. this point, I owe it to you guys to stream that design, because there's a bunch of different facets of that thing that I want to get together. Trying to do everything at once. What's going on? Oh, there we go. There we go. All right. Severely reduced amount of solder. I can see 2 pins in there, and I see a track in between them. Good stuff. So that should probably get the rest of this thing working, now that we've checked over it 70 billion times. In spite of the manky nature of what I'm putting together here, you can see the utility behind this, right? I'm putting together a circuit that's going to perform filtration tasks and give me an idea of how this whole thing goes together. Now, I really should have done it in the in the breadboard, you know, all in the breadboard, but this is a parts issue more than anything else, is that all I've got are surface mount devices around here, and because I build a lot of stuff like this. If I'm going to build a one-off thing, I'm not going to commit it to a circuit board. I'm going to build it on a perforated prototyping board. A lot of different, like, programming adapters and stuff. None of them are in here. Okay, fine, be that way. A lot of, like, programming adapters and, like, digital circuits that we put together are done that way. We just haven't had a project in a little bit that's fully utilized all those techniques. This one is not melted. All right, you're hired. You're hired as not a not melted potentiometer that goes in here. Congratulations. Your W-2 needs to be in by the end of the day. All right, let's put this thing right directly on there. 2 holes away. This thing, make sure that lines up properly. Plug it in, and we should get fucking nothing. God damn it. Piece of shit, mother... All right, okay, all right, okay. I'm calm. Everything's calm. I'm calm. We should be seeing exactly the same signal coming out of the other end of this thing. So, is it still shorted? Maybe we jumped the gun a little bit? That's absolutely the wrong view. I could have jumped the gun. Let's check to see whether or not it's shorted. This thing is powered, so get out of there. And then let's check ohms between here and here. 1.7 mega ohms. Yeah, that's fine. Here and here. Mega ohms. Here and here. Should be exactly the same. It is. Here and here. Gucci. Okay. Okay, Paul. All right. So what else is wrong with this thing? There's still something wrong with it. That wasn't all of the problems. That was a big problem. It wasn't all the problems. So we gotta trust in our dust here. We gotta make sure that this thing is that shorted. Are those 2 pins shorted? Man, every like short circuit detector, visual short circuit detection thing that I got going on in my brain is telling me that these 2 are shorted, but only one way to find out. Mega ohms between these. M. There's a big old M on that meter. 500K. That's acceptable. So yeah, these are not shorted to one another in spite of the fact that they look like they are. I think it's just because I poked through. All right. So this one and this one should have 212. Or sorry, 2 point. Ah, hello. Oh, wait, no. That was my probe. My probe slipped. 2.7K. All right. Between you and you. I'm so close to just being like, analog audio sucks, and just taking this for like digital. Just take it digital. Fuck it. As long as I can get an FPGA to run off of 10 milliamps, which might be asking for a lot. No continuity. Good. Continuity. Good. From this pin to here. Good. Input from the board. I can't get to the board. All right, fine. Input from here to here. Good. Like 0.7, 0.6. Input from here to here. Input from here to... Okay, darn it. That was fine. 2.7, 2.7. Continuity. Continuity. No continuity. No continuity. U continuity. Continuity? Continuity. God damn it. I don't see any problems with this freaking board. I don't know what the problem is. Where's my frequencies coming out of you? Is it maybe I'm not like connected to the chip itself? These are floating? No, those are connected. They look like shit, but they're connected. You. Nothing. You to you. Something. You to you. Something. Okay? You to you. Something. This thing is getting me angry. This is the frustrating part, is when everything looks like it should work perfectly, but does not. Wait a minute. You've betrayed me for the last time. No, wait, no, never mind. It's making fine connections. Totally there. It's still there. Power, we know, gets in because it draws enough current. There's no shorts on any of this stuff. Going from this center pin to the output, or sorry, the input should be 2.7. 2.7. Going from the output to the output should be another 2.7, right? Oh yeah, 0.4, because that goes all the way over to here. That's making a connection. These aren't shorted for the 15th time. Nothing. Nothing. I don't know what's going on with this circuit. Bad silicon. Or maybe I'm just testing it wrong, or I don't know. Check weird connections. All right, let's check over some weird stuff. So from, I don't know if you guys are familiar with this circuit yet. I guess everybody is getting a little bit more familiar with the circuit, huh? If the chip died, I'm gonna cry. Nothing there. What is that? 2.27 mega ohms. All right, yeah, that's fine. Okay, yeah, so I'm starting to run dry of ideas here. Here to here. Actually, this is the same as testing this, which we know doesn't do anything. What is this junction? There, there. Oh, that's actually, yeah, that should be separate from this. I'm not getting good contact. Hold on. My hands are all in the way. Okay, we've made an oscillator circuit, which is fine. That means nothing's happening in there. I just saw this little glint of light. Thought that was something. I thought it was something. I dared to dream. 6.8K. That's okay. The problem with doing that, like, yeah, so what if I change this out with a known working board? I mean, that's the eventuality of it, and that's why I should have spread the circuit out more, because it's hard to get to these resistors by way of my jumping all these freaking wires all over everything. If I spread out a little bit, these wire connections could be under the board, and I would have a much easier time of this. But the problem is, I need to move these resistors over to another board in order to mess with this thing. Because I still don't know if I need to change out the 2.7Ks in order to alter the gain and stuff. Although we did see on the outset of the EQ, we're seeing good results. So the question is, like, I don't know, do I take this EQ design and I move it away from opamps? I'm not sure. They seem to be pretty power hungry. I just don't know why this one specifically is not working, because it has every advantage that the other ones have. And I feel like I've ohmed out just about everything. In the real engineering super dome, in the danger dome of actually really doing normal engineering, I would take the schematic and a highlighter and ohm out every single connection. I don't want to do that. It's really annoying. It really sucks to do, but you know, sometimes you got to do it. Sometimes you just got to do the due diligence. So, I mean, there's a chance that the op amp is the primary fault at this point. That's what Schmide basically said. Any other? Well, no, we checked for shorts. We already sprayed for shorts. No short. No short. That one's supposed to be a solder bridge. Like a bunch of missed calls. What's going on here? Probably should have turned on my ringer, but I have a feeling they're not legitimate, because I don't think any doctors are calling me at this point. None of them left a voicemail. Okay, so there's your indicator. I'm gonna turn my ringer back on because I don't have my phone in my pocket. All right, there we go. Anyway, back to what I was looking at. Doing a visual inspection of all the connections on this thing, right? Oh my God, they didn't do anything on the underside. All right, so I've got ground coming in here, and that is zero, or sorry, this pin right here is our virtual ground. That's what all the components that have a ground symbol go to. So that comes across here, barely connecting, that looks like a cold joint, but I think it's okay. Coming all the way over here, not connecting to our actual zero potential ground, comes all the way out here, and it goes to, yeah, the resistor and the capacitor on either side. The op amp, however, since it's operating in AC, is getting a 0 volt potential ground. That 0 volt potential ground does not make any cross connections or anything like that, according to our ohming it out. Let's see, and that only goes to there, and that doesn't have any shorts or anything else like that on there. Our input comes from the white wire here that goes over to the potentiometer. It has a 2.7 kilo ohm resistor on it that goes to the non-inverting input, or no, the inverting input of the op amp, and then it's got a feedback resistor of another 2.7K feeding back and going into the other side of the potentiometer. The inverting feedback is connected to the center tap of the pot with, and I guess this is canceling out the waves. That's how it's doing it. So the center tap of the cap, or the pot rather, comes through a capacitor, through a resistor, probably getting it down to whatever voltage potential we need in order to get the gain out of it we need. And then it goes through another filter, like, because that's cutting a what is it? Cutting a DC component, and then we're putting it through a resistor divider, as well as a cap going to ground. So we've got the weird filter shit going on. 1 over 2 pi RC. 1 over 2 pi RC. That's what that filter is. So whatever that is gets fed into the, and that's what this wire is, it gets fed into the inverting input of the op amp, or not. That doesn't look very good. Doesn't look very connected to me, although it is. I like bent up the pin by now. No, that's not a very good connection. Maybe that's a problem right there. Yeah, poke at the capacitors. I know, at this point we're kicking the tires. We're kicking the circuit's tires to try to get that last connection in there. It's not very clear on the microscope camera, but this is the stuff that'll drive you nuts. And again, as I say, spread out. Spread out. You know, I'm not just saying spread out because I'm a weirdo. I do shout it at random people on the street, and as soon as the internet finds out about that, I'm going to be in big trouble. This wire has seen better days. That's part of the problem, is that wire sucks. It's actually in very bad shape. I don't think this is going to fix it. I might as well try it now, though. It's the only thing that I could see to alter. Let's just try it. And, you know, I don't think it's the values that I chose, right? I don't think so. the values that I chose for the components, I'm using fairly common laissez-faire. Everything is fairly jelly bean at this point. If you know, if I blow a circuit in my brain over this, it's possible that we could just commit this to a PCB, because I could build a dual filter on a little PCB, and then that would just plug in. I get 5 of them too, so I'd get 5 of these. Yeah, it's still reducing 73 down to nothing, and it shouldn't be doing that. 73, which is this one here, and 237 are far enough from each other that nothing should be happening there with those frequencies. So we shouldn't be seeing a reduction in the output. We're still seeing a wave as the output, and that's actually pretty good. That's not the circuit. There we go. This is the circuit, right? And so from the other ones, when we were looking at the other what do you call them? The other circuits, like I switch over and we look at the higher frequency one. Wait, this one's higher, yeah. If we switch over to the higher frequency one and I power it, oh, was my wire loose? That could have been it. But you can see that it's not altering the gain at all. It's not adjusting this frequency, so it's not supposed to be doing anything to it. That's right. I think I get 10. You're right. I think that's what it is. Whatever. You get what I mean, though. What are the pods for? They are manipulating the frequencies that are going through the mic setup. What's happening is each op-amp is responsible for a specific center frequency, and it's got a certain amount of spread to it. We fixed those frequencies by choosing a value of resistor for it, whereas on this circuit, what Elliot Sound is producing is adjustable. However, we have our fixed frequency filters that can enhance or tamp the specific center frequency that they're looking at. And so we're trying to eventually replicate my EQ system and phantom power it, which is getting to be a little bit of a problem because we're having trouble with the amount of current that's going through here. We've had this thing configured in a bunch of different ways. Oh man, I do the wrong yaw every now and then. I correct it when I see it because it does irritate me, but I try not to be like that. The internet has enough pedantry on it. Okay. So you can see here that a good filter running properly is not going to alter the audio at all at the frequencies it's not supposed to be looking at. So if I plug this one back in, and now I think I've got a slightly better power connection to it. Got the audio's all over the place. It's in AC mode, so those waves moving all over the place are just kind of like normal. So I plug this one back into power, put the output to the output, put the input to the input. I got the pass over here. Yeah, it's just killing the wrong. It's killing the wrong stuff, and this is the important filter. This is the one that I need. I need you to work, filter. Please. That's so weird. That's so weird, chat. I don't know what's going on. I don't know why this is happening like this. So what we have is this right here is my microphone setup. Very similar to my actual microphone, this thing. This thing gets better gain, and I don't know why. That thing gets better gain, but it's essentially this, right? It is this. And so I've built it onto this thing, and now we need to add equalization. That's the whole point of this project, was to get sound very similar to what I sound like out of my microphone initially so that I can plug it into my other mixer and get good audio. But I had to build a little daughter board that contains the parametric equalizer filters on them. We found out we can't run all 3 of them, which is 6 filters. I don't need all 3 of them. I could use 2 of them, but 2 of them is even too much current for this thing. So if I do a low cut and a high cut, can I get similar audio out of this? But now we're having even more problems because the filter frequency range that I need the most, nothing. Doesn't work. I don't know why. Now, it could be the opamp at this point. Could still be some of the connections, though. And this is where we get into actual troubleshooting of electronics. This is the complicated thing. Really annoying, though, because usually I'm proficient in this kind of stuff. What does voting OP mean? Wait, what? Oh, you think it's the opamp. You guys all think it's the opamp. I don't think it's the opamp. I'm putting it in the device so that I can tilt it. I still think it's those wire connections that are all fucked up. Hold on. Let's get the capacitors out of here and let's take a closer look. That's okay. All right. You're generating conversation, right? That's good. Yeah, like those wire connections are just totally fucked. Now keep in mind, this is my method of making sometimes permanent CNB1T. Thank you for following. This is my way of making semi-permanent circuits on perforated prototyping setups. It's a little janky, but aren't we all? What about this connection? This one's looking a little weird. That one's looking a little weird. Let's poke at this with a knife. Ow. Ow. Damn it. Ow. Ow. I said poke at it with a knife, not me. We would have seen a resistor getting hot. Oh, hello. Mr. I peer back immediately wire. Jank number 2. Let's solve the problem. I'm going to cut this a little lower. Or not. Come on. Yeah, get that out of there. And then solder that a little better. I don't know. It looks like it's still connected, though. Still looks connected. I'll give it a dollop of solder, though. See if that cleans it up. That's like, because I'm seeing like no input and output, and that's why I'm like concentrating on connections instead of the usual suspects here. I don't think the op-amp is bad. I just think maybe it's not hooked up. But yeah, I bit off a little more than I can chew in terms of building these. I probably should have spaced out a lot more. Made it a much larger circuit. Oh, fuck. God damn it. That thing wandered away. You get back over here. Go to your home. I guess that's connected. For better or for worse. Yeah, that looks good enough. I think that's all I can do now. I think that's everybody, aside from that one, but that one looks connected to me. It just looks bad. If I gave myself more room, it wouldn't look so bad. So you guys got to remind me in the future to space out more. Reach out and touch space. This thing is just connected to that pin. It's just very gross looking around it. There's like a lot of frayed plastic that's getting in the way. See if I can't just like clean that up. Just get rid of it. 650 Fahrenheit is what I use. Reach out and touch grass. Do 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 do. Yeah, it's not a great connection, but I think it's there. More like a Craigslist missed connection. I know, right? Listen, backseating is such a tough thing in this hobby. It's such a tough thing, because like sometimes you guys tell me stuff that I need to know, But like, I can't encourage it because then I don't make the mistakes that allow me to show you guys what I'm actually skilled at, which is this, the troubleshooting. Oh, if you're so skilled, how come it still doesn't work? Well, that'll get you banned. It's tough because you know, chat is rude by nature, and I really wish they weren't. And I have an aversion to rudeness. It really feels like there's a connection in there. Like those are actually making contact. I don't think they are, but the more I dig this out, I guess the better it'll be for it. That might be good. I might be able to get that working. That doesn't make a connection either. Oh wait, no, that's supposed to make a connection. That's supposed to, derp. We didn't find any shorts in here this time. That was the problem with it, was before we had these two shorted to each other. All right, so for the most part, everything ohms out all right. Technically, there should be continuity for this thing, so let's just get the caps, or sorry, the potentiometers back in, and we'll see what happens. At which point I rage quit. I smell blood. Okay, it's just me. It's just me. I smell blood for some reason. I've been touching metal too much, I think. You know, it's probably this vice. Yeah, it's the blood of my enemies. On the vice, you know how it is. No, it's just filthy, that's why. Please. Please to be sending whole wave through. Damn it. Hold on, it's not plugging in. There we go. God damn it. Piece, you. I don't think it's a matter of adjusting it, right? We shouldn't, unless I put a bad value in here. I guess that could be part of it. So let me just take these over to their, it's righty-loosey in this case. Or no, lefty more volumey. I do see little jumps in the waveform. Is it that this isn't like connected properly? It does seem kind of loose in there. Should be making decent contact though. God, this is frustrating. It's possible that these are affecting the side frequencies too. They're not all that isolated. That should be at max. Let's take this one up. Come on, buddy. Ah! Keeps slipping. Yeah, at this point, I'm wondering if it's the opamp. In which case, I got to do surgery in order to get it out of there. We'll get it out of there. We can do that. And then at least we'll know all the connections are good. Yeah, that's at max. All right, we gotta do some opamp surgery here, folks. Let's get this thing out of here. Let's get it out of there. So I gotta get the opamp out of this. The more I work with it, by the way, the more, you know, frazzled this circuit becomes. But we can get the LF353 out of this thing, and we can see what we can do to put the new one in. So let's go to there. Let's go to the microscope. All right, so we're extracting the IC. Any of the wires that are sitting down on an adjacent circuit connection, I will leave alone. Any of the wires that go directly to a pin, I'll bend back. Power the iron on. We'll still be using the big tip. Well, the relatively big tip. And then I'm going to get in there with my tweezers. Actually, a pin tool is probably all I need. Yeah, this is like real deal surgery here. Probably tweezers, although I don't want to crush the wire jacket any more than I already have. It's already a pretty traumatic procedure. That shouldn't be connected at all. It looks like it is. That wasn't our problem because we did ohm it out. It's just that as I manipulate the solder, it wants to flow. Right, blue wire. Cut the red wire. Cut the blue wire. They're all red. All right, out of the way. That one's like a real shit show of a wire, huh? That one stays. This one moves. This one moves too. That one's all frayed beyond. God, it's such a mess just because we've had to rework this one so much. Those two are just coming in from over here, huh? Same with those two. And then I think that's us ready to remove it. Now, if we're totally writing off this chip, I could destroy the legs. I could sweep the legs and then get this thing out of here, but I'll be a little bit more civilized than that. Get under it and pry it up. Second seafoaming did nothing? No! What are you specifically trying to do? Why does Poseidon have to get into this? I can't talk about that. The question is off topic, but feel free to ignore. Were IEDs complicated enough to have anti-tamper features? I'm like, that, no, can't, no. Can't tell you guys how to make a bomb. Jesus Christ. You know? You can look up like famous FBI court cases about bombs. There's an article called Left of Boom that kind of like super old. It's like from 2001, but it goes over like what I was doing to a decent amount of detail. Yeah, I could have done yes or no, but I had to go into more detail. All right, let's get rid of the excess solder, because we're going to be adding more excess solder ourselves. We don't need any help. You can see my little bed of Captain tape where the action happens. Man, this is disgusting. My work is so gross. The other filters work. I don't know. I think it's a fine method. Desoldering braid. It's designed so that the surface area between the strands does a capillary effect on the molten solder and sucks it away. It's as close to visual asthma as we get on this channel. All right, I gotta get Opamps out of the drawer. Where are they at? I'm just down here. Hold on. I've been a lot louder this stream than I normally am, so my voice is feeling it a little bit. Let's see what we got sitting down here. So you can find our LF353. Built the engine 1500. Oh, I see. You're just going to spend the money on a new engine. Because, oh, cylinder 8 had a misfire. The compressor was 30 psi. Put the shitty borescope in there, saw a bunch of carbon. The Seafoam cleaned that up. But it either ate a valve seat or something. Ah, that's tough. There you go, LF353. That's what we're going to put in. I'm going to put a new one of these in there. I don't think I put the other one in backwards. That sometimes happens. But yeah, pin 1 is on the upper left, and pin 1 is the output of opamp A. And we've got the little piece of Captain tape there in order to shield the pins, and I can connect the wires to them. So let's get this in here. A good soldering iron? Ooh, I don't know. I actually don't know. I don't know. I haven't had an entry-level soldering iron for decades. For a lifetime now. So it's hard for me to figure out what exactly I should recommend to you guys. Yeah, a temperature control one, the TS series or TS80 or whatever, Those TS soldering irons are really good. They're a little bit above entry level, and it's like more expensive than probably the soldering iron that you should get, because you don't know, I don't know, we don't know. We don't know if you're going to stay in the hobby. So if you're going to do an occasional repair, something with barely any temperature control is perfectly suitable for you. Perfectly fine. It's fine. But if you're going to be doing a lot of soldering and kits and things like that, and repairing, you know, your friend's stuff, and et cetera, et cetera, et cetera, you get what I'm getting at. But yeah, that's all. It's all down to what you're going to get out of it. I mean, I'm a proponent of the Adam Savage philosophy in terms of buying gear, which is buy the cheap thing, use it. If it breaks, you got your money's worth out of it. You can buy another one. You reevaluate once you've blown up the first one. Yeah, cheapo Amazon one that does like basic stuff will do you great, and you're not wasting your money. But if you find you need more, go buy more. Ta-da! Philosophy. See, I'm anchoring down the side pins, and then we reintroduce all the wires to everything. And then I can prove to chat that it was not, in fact, the opamp that was bad. Or, hopefully, I'm proven wrong. I think I should get the other soldering iron tip for these. You do that thing that Tomato does, where he's like, you owe me $50 if I'm wrong, or you're right, or whatever. I'm not doing that. No fucking way. Feel vindicated when you're right. Vindicated. Well, there's a first time for everything, so we'll see if chat's right about this or not. That felt weird. Felt like I broke something off there. Those are like kind of held above, but not really. It's tough to get these side pin connections when you don't spread out, like I've said. Spread out. Gee, what was I thinking? This is a nightmare. Or daymare. My iron on? My iron's on. I just can't get heat into the weird structure down here. Cool, yeah, let's solder both of them at once. All right, I managed to pull that out of the fire. I pulled that one out of the fire, chat. I think I got a connection there. Yeah, just like give yourself room to work. Holy hell. Don't be like me. That was almost, yeah, that tried to pull a solder bridge. I just want this thing to work, man, you know? I'm tired of this. I mean, we know the filters work, so, you know, I'd almost accept committing this to PCB at this point. Aside from the fact that we've run out of current, and I don't want to make an additional current injector into my phantom power setup. The alternative, if everything here fails, at least I know what to do in the future if I want to build my own audio filter setup. Like, I could make a little go-between box that you would plug in line with each of your microphones that would run off of its own phantom power, which I'm not too cool with. I'd rather it just all work on its own, but if I have to do that, I could do that, or I can struggle through setting up this microphone, the lavalier microphone, within the Rodecaster Pro and get it actually to run. What kind of temps can the IC handle? Look, you guys are... my God, why didn't I think about this before? In all of my 30 years of doing fucking electronics, I never realized that if I put too much heat into an op-amp, a literal fucking nuclear-safe op-amp made in the fucking 1960s, Back when soldering irons were a literal iron that you would put on a heater, could blow up. No, it's fine. The temps are fine. Very difficult these days to blow up. When you're talking about temperature sensitive electronics, you're talking about much more complicated stuff. Much more complicated stuff. We're in the land of like Radio Shack, like 1990s opamps. What is happening with this wire? This wire is all over the place. Hold on. You put hashtag soldering too much on there. Of course, you're going to get some sass from me. You put hashtag soldering too much at the end of your question where you weren't trying to be insulting. Yeah, well, you get sass. All right. The wide tweezers are the ones that actually grip those wires the best. They grip everything the best. I guess my level of precision work, you know, these wide guys are where it's at. The thin ones tend to do this. They pizza when they should be chopsticking, and they go like this, and then they fire your part out at like an incredible spin out of the front of them. So you're like, all right, let me just boom, and then your part just flies away. These are really good because they've got the wide front. They've got enough grip that I can pull on stuff, and then they're also a little bit predictable through the angles that you take them on, and they don't do this. So, all right, now let's watch it not work again, and I get increasingly frustrated. I didn't want to rage quit today. I thought we were on a day that wasn't too susceptible to rage quit. I'm going to bend that center pin. So this thing is a little loose in the pins, so what I'm going to do is I'm going to bend this down a little bit. And that'll just stagger the pins by like 0.5 millimeter so that when I get them to plug in, one is pressed against each end, and it makes a better connection. Not a great connection, but a better one. Thin tweezers is consumable. I've had these for so long, it's ridiculous. It's been like, oh my God, where did I even get these from? I might have stolen them from the government. Those might be FBI tweezers. Dun, dun, dun. The guy sitting behind a computer console in Langley, Virginia is like, got him! Like, busts out the door. We got him! Everybody's getting in helicopters. Fucking the same results. So either the problem is somewhere else, and I've hooked this thing up exactly the same way, or there's some characteristic of this circuit that I screwed up. And it's doing, as long as it isn't the IRS, some characteristic of the circuit that I'm not representing properly. And so something has gone awry. Let's go with the opposite value for the... See, even when I pull these out, it's doing the same thing. This leads me to believe that it's not specifically the circuit, and it's something else that I did. Oh, wait a minute. Bad perf board? Bad perf board? Perf board? Bad perf board? Perf. Hey, buddy. Bad perf board? Could it be that I chose a bad slot in the perf board? Could this be where my problem lies? Perf? No, not there. I think it's on the phantom power pin, maybe. I don't know, though. Because I'm getting more gain as I wiggle things around. So I could have a bad slot on the perf board. In which case, how can I compensate? What can I do for this? I can move this to the left one, as long as I move my phantom setup, or my virtual ground setup over. over a pin or two to there, and then I can scooch this over one pin. Nope, that didn't do a damn thing. That didn't do nothing. No. That wasn't it. That wasn't it. Yeah, okay, never mind. That wasn't it. Something else is awry, and I don't know what, because we ohmed out all the pins. We did solve a couple little issues that this thing was having. I reconnected all the pins. Did I reconnect all the pins? Power. We got that pin. We got... Oh, we might have a short. Hold on. That kind of looks like a short. Okay, hold on. More investigations. I'm gonna get this fucker working. Nah, it's, you know, it's a roller coaster of issues. That's what it always is with these things. I didn't like the look of this. I don't know what's going on up here. I don't know if that's shorting out or what. I need to alter that a little bit. I didn't like the look of this. As I move, it's like maybe I should start replacing some of these wires too, because they're starting to look pretty bad. I should just run a hard line on the very edge. I want to get this thing working, guys. I know what I'm doing. I'm not, I know how to do this. I know what I'm doing. I feel like I have to do something digital after this project, just so that I can feel proficient. This analog stuff really separates the boys from the men. And the girls from the men. And the men from the men. Amen. All right, that looks sufficiently more separated. Point to point the whole circuit. That's basically what we're doing. When is it worth just rebuilding the whole module? 2 hours ago. All right, let's try this again then. It's like, hey, maybe I chose a bad value. 2.7K, 682 for both of those. Yeah, there's a sunk cost fallacy that's going into this. I mean, the fact that we got like 2 of these to work properly and the effect of them is dramatic means that I could probably like, reevaluate what I'm doing here. But I don't know. I'm still plugging away with this. I mean, the fact of the matter is, if I can't get this below, I might not even be able to get this to work in the first place at all. Not this specific module, but I mean this scheme. Now that we've seen the limitations on the amount of current that we can run, the LF353 is out of the question. I don't know. Well, when I first plugged it in, I saw a little bit of a wave, but we've still just got this like pithy output from the whole thing, and it really shouldn't be like that. Like I said before, we should be seeing the same amount of gain coming out of this thing as we're seeing going into it. Especially this frequency is not the frequency that this thing alters. So something else is going down here. Something else is effed up. As far as we're concerned, I mean, we ohmed everything out. It's like, regardless of whether or not I have the caps in here, this thing isn't working. What the fuck? Why? Wait a minute. This doesn't make any goddamn sense. Wait a minute. Hold on a minute. We weren't powering it. Parallax! All right. You guys want to know what's going on? You guys want to know why this circuit isn't working? Why we wasted about an hour and a half, 2 hours of our time? The purpose of the dot on the IC is to show us what pin 1 is. Pin 1 is very important to know. Parallax! Once again! Fucking parallax. Alright. Alright, I get it. Fucking parallax. And once I plugged the... Okay, alright, this isn't... I've tried to do it so that you guys could see. That was my problem. My problem was having chat around. I can't. Fuck. Okay, hold on. Let me just get this thing in there. Let me get this one in there. Plug it in. Oh, dear God. You know, not exactly. I was hoping that would fix it, but I don't really think that's the result we should be getting. I should be seeing exactly this here. That should be the same, not drastically noisier and more horrible and cursed. So it's still got problems. It's still got problems with this thing. Still got plenty of problems with this thing. Let me just make sure that everybody is all hooked up. Yeah, that's the thing. You know, that's troubleshooting for you guys. You guys on Twitch, those of you who are less experienced with electronics, you're looking to get into this stuff. It takes a certain amount of adamance in order to go through your circuit and constantly correct every single little thing that might be going wrong with it. You really need to be able to stick with stuff and just, you know, put in all the cursed work. Just making sure that my pinout is right. 1, 2, 3, 4. Yep, that should be all right. Plug it in there. Plug it in there. Now I can take the oscilloscope and I can poke around and see what's happening to our waveform. I have a feeling it's just our waveform just dies immediately. I have a feeling that's what's going on here. Because alright, so if I take channel 2, which is the return channel, which is right here, I pull that, and I bring that over here. Now I've got a little probe that I can poke around with and I can see what's going on. So, you guys won't be able to really see what I'm doing, but going into the potentiometer. Actually, wait, output from the first filter's over here. Just plug in there and see what happens. It's the first filter. It's either the whole board or the first filter. If I isolate the first filter. Nothing. Yeah, so it's not getting through the first filter at all. So let's see where that signal's going. Here, let me do this. And then we'll go over to the microscope. Yeah, you guys don't need as large of a view on that, of the scope. You can see where I'm poking a little better. So here's the circuit that we're looking at. Better for worse. Let's get that in our view. See if we can zoom out a little bit so we can actually see the whole thing. Close enough. All right, so I know that the connections on this thing look pretty rudimentary. But one of my big concerns about this circuit is that if I take one of these out, nothing changed. Nothing changed on the waveform. Yeah, this is the pokey bit. This is where we get to poke it. How is that happening? How is nothing changing on the waveform? Well, okay, partially because I wasn't even plugged in. But yeah, if we're looking at the output is over here. It's right here. And see, we're not getting anything happening. So I take this over here and I look at the input. The input looks exactly like the output. Well, that's a good sign. That's a good sign. That's the basic requirements of a filtration circuit. What about our output? Fucking nothing. There's nothing there. This is what we're giving it. This is what we're getting back. So, virtual ground is here. That's not going to show up on an AC probe. Over here we have one of the inputs. Can't really get a good hit on that. Ooh, that looks dirty. That looks dead. Okay, all right. That looks the same there. What about after the cap? Yeah, there's a wave there after the capacitor. It's inverted. Pretty dirty, though. Looks like a noise wave. But then at the junction of the filter, It's just noise. It's just like DC noise. Damn it. So I mean, our first filter is the problem. We've got this documented. What about the output directly from the chip? Yeah, it's just nothing. Output on the pot has a little bit of a wave on it, and then the input goes here. That looks exactly like the input. Looks pretty good. What if I cut off the pot and check it out up here? Same exact thing. Yeah, that's good. So then, ooh, crush my balls on the stool. Ow. Damn it. Ugh. It hurt a lot. When I'm sitting and I'm leaning forward like this and I'm trying to get real close into the circuit, I will crush my balls on the stool. It's not a fun time. Where's all that wire over there? Wait a minute. I got like a ton of wire sticking up over here. That shouldn't matter though. The output over here, I'm wondering if it's not connected properly. Was my head under the microscope? Yeah, it was. God damn it. All right. So I'm at the point of rage quitting for now. I don't think a lot of the problem is my own janky circuit, but I know it didn't help in terms of troubleshooting. This looks like hell, but it is functional and it should work. Something is not happening. Something's not happening in here. And it might be, you know, maybe one of the connections is a little funky, or maybe there's a wire that I'm not seeing properly. In the end, this one should work like the other filters. So I'm going to take a better look at it, maybe when I get a little bit more time this evening or something like that. And I'll see if I can come up with any reason why this thing should be such a fucknut. And we'll come back and we'll either work on a little bit of audio stuff or we'll do Fusion 360. Because, wait, one sec. What happens if I put this back in? Put that back in, and then I push on this guy over here, where that cold solder joint was, right there. Okay, nothing. Just as I suspected. I'm wondering if maybe the filter values are bad, or I did something dumb. But it is just the one board. The other two boards are functioning just fine. I wanted to be able to replicate my settings initially, and then be able to like plug into them and see the effect of the different settings on the rest of the audio. But apparently, it's being an absolute pill. I don't know why. It seems like, maybe one of the connections is happening properly. Is it that one? No. That just introduces noise to the base audio signal. Yeah, what we're looking for is for the output to look just like the input. This is before we even change frequencies to the one that this one is supposed to be adjusting. That's my frustration with this right now. So yeah, we replaced the chip. It didn't do anything. Pin 1 is the one marked with a little dot. And pin 1 is an output. And we've traced that output all the way out to the yellow wire. That's not a parallax thing. I'm looking at that from the side. That's there. That's the way it should be. Right? Yeah, okay, yeah. It's not a parallax thing. Yellow wire jumps it over to the other side where it goes into the white wire, which is the input. We did have a parallax problem there, but we solved it. So now this thing gets power. It's not doing anything with the power. I don't know what the hell the deal is with that, but the power wires are starting to look real bad. Starting to look real bad on the power wires over here. But unfortunately, not bad enough to be affecting the circuit in any way. Just janky. Oh, chat. I don't know what to do, man. This should have worked. All the others did. So if it's a value problem, well, we need to split the circuit out a little bit more, make it more functional, and actually put these wires under the board and spread out all of these different functional blocks, right? Move the resistors out so they're a little bit more spaced out. And then I'll be able to come in with a soldering iron and change out values more easily. I didn't really plan for that. I just wanted to get it working, which the other two circuits do. It's just a little frustrating that we got like an audio kill right here. Why you do this? Do you not get power? I think it gets power. Hold on, where's my probe? Where's my probe line? Which one was that? That was this one here. Yeah, that's the output. It's just nonsense. Or no, that was a power. Yeah, the output's just nonsense. There's just nothing. And there should be a waveform there. Ooh, there's a lot of noise on the power line. Whew. Oh no. Well, it's millivolts. All right, buddy. What's the deal here? Why don't you function properly? All right, so rage quit today. I didn't want it, but that's what we get. And that's what happens when circuits get me all worked up. Getting all hot and bothered by circuits. Can't get my ins and outs straight. I made a no-pass filter. Yes. Look, if I put it on the lower frequencies, or the higher frequency one, it doesn't touch this audio at all. And I don't think this is a matter of the filters going on top of one another. You can see there that it's doing a great job of just doing absolutely nothing to the audio. And then if I put on the lower filters, this low frequency gets enhanced. Enhance. So like the filter design works. Okay, it's doing nothing. Okay, okay, I put it in the wrong things. Wrong things. All right, now it's in the right things. Nope, it's not. Is it not? No. Oh, does that break it permanently? No, wait, no, I didn't do the craw. Okay, hold on. Craw. Yeah, there we go. If I put it on the lower filters, boom. A you shall not pass filter. The Gandalf filter. Damn it, camera. Yeah, I got it plugged into that one right now, and you can see that it has a very nice effect on the audio. It's actually enhancing it by the 1.4 decibels that I have it set to in software. That is the same circuit as the one below, only it's built on a slightly different perforated prototyping board. Slightly different perforated prototyping board. This one has more space in between the squares, which is actually good. I didn't think that would be good at first. This one has a little bit less space in between the squares, and so it's much easier for me to vet out on this one whether or not anything is shorted to itself. But it's the same friggin' design on both of these. It's just for some reason that one right there will not function, and I don't know why. I am going to put in a little bit of midnight, well, maybe not midnight oil. I'll put in the early morning oil on it, and if I still can't get it to work, then you know, we'll do. I think we're going to do Fusion 360 tomorrow. I got to keep the variety going. I got to keep the variety. A lot of the positive feedback that I got in the early days of this channel, the stuff that really built up this channel, was, hey, Bother, I love that you're always working on something different. And while they're the same projects rolling, I can still get more appeal and you know, keep the variety going so you guys don't get sick of looking at my fucking face all the time. We can keep a little variety going in here. We'll do something different. Tomorrow is Friday, and we need to let our hair down a little bit. Doesn't really work for me, although my hair is getting longer. But yeah, we need to let our hair down and do some other stuff around here. And so what we'll do is we'll work in Fusion 360, and we'll make some stupid piece of plastic that I can then print out and complete the hardware section of Burn the Subs. Now, I would love to have an assembly day, but I'll have to figure that out. Like a day where I'm just building Burn the Subs, but the problem is I got to be over there. So, and then on Saturday, I'll figure out a game to play. I don't want to keep hitting Satisfactory, but I do want to keep playing that game. I'm not done yet with Satisfactory. Although I have gotten things to where I want them to be, and all that's left to do is to like plug in stuff from far away. So I don't think I'm going to do Satisfactory. I don't know if I want to return to Long Drive yet, even though I do want to continue that save game. I should probably find a third janky game to play or something of that nature. I'll think about that. You know, we'll think about that, and feel free to suggest stuff in the gaming channel, but you're going to get rejected. It's not my fault. I want to play a variety of stuff, just not to hound in on one singular game and make that my entire channel's personality. Davies. No. plays other stuff. What else is going on? Like, should I raid, or is that too embarrassing? Phasmo with PPs? No, no, no. I don't like Phasmo because I'm afraid of ghosts. You know, I actually believe in flat Earth, and that's because the oceans are not carbonated. What the hell's my like other Twitch? There it is. Oh God, is everybody going to be playing the remasters? Dex Bonus is doing knitting in Makers and Crafting. Let's hit up Dex Bonus. We'll do that. Is it just Dex Bonus? Just Dex Bonus? Is that it? Is that it? That's all there is? Yeah, that's all there is. All right. I think I can do it. I think I can do it lowercase. I can. It worked. Oh my God. Yeah, let's do that. And then I'll be back tomorrow. Same bat time, same bat channel. Let me give you guys the end card before we adjourn, so that in case you want to join the Discord or anything like that, there's all your links. 20 hours, 17 minutes, and 2 seconds you guys have. Choose your time wisely. I don't fucking know. I don't know if I'm going to be able to get to this before tomorrow, but we'll see. And I'll see you guys on Friday, all right? Oop.